Welcome students. In this class we will be learning about quadratic equations. Now the general form of a quadratic equation is in this manner: ax squared positive bx positive c is equal to 0. Now there are four different types by which we can solve a quadratic equation. And the first and the most popular one being using the technique of factorization. Number two is using the formula method. Number three is using the concept of completing the square. And the final method is using graphical technique. Now, apart from these stated methods, there are other techniques also which we will come across once we gradually raise the intensity of the subject. Now, to start off, let me just show you how the factorization technique works. We have this question: x squared negative 3x positive 2 is equal to 0. We expect it to solve. So when we say solve, the question wants us to find the values of x. Simple as that. Now to apply this technique, the coefficient should, in fact the coefficient of x squared is taken to be as 1. In other words, you can apply this technique safely if the coefficient of x squared is equal to 1. Now what we need to do is we take the quantity 2 and we multiply with the coefficient of x squared, and that is actually what is going to help us in judging. So we multiply that and then we place it over here. So 2 times coefficient of x squared, which is 1, gives us 2 there, and the coefficient of x is going to be negative 3. So you place it. Now the main idea is to find two quantities, two numbers, which when added would give me the quantity negative 3, which when multiplied would give me the value 2. So what would those numbers be? Now clearly I can see that if I were to have, say, 2 and 1, 2 added with 1 will give me 3, but I need to get a negative 3. And not only that, 2 multiplied with 1 gives me 2, but the only catch here is I need to get a negative 3. So that is only possible if I have a negative 2 and a negative 1. So when negative 2 is added with negative 1, I get negative 3. Negative 2 multiplied with negative 1 gives me positive 2. So when you're writing the factors, you got to write it like this: x, the quantity that you see here is negative, so place that, multiplied with x, the quantity that you see here is negative 1. So this is going to be the factors for this equation. And clearly x negative 2 is equal to 0, or x negative 1 is equal to 0. From here you get x is equal to 1, and from here x is equal to 2. So therefore if you are expected to write the solution set, then it would be 1 comma 2. So that would be the solution for this particular question. Now let's move on to do one more question. So this is first question, question number 2. Say for example you got x squared negative 5x positive 4 is equal to 0. So you draw a wedge like this, and 4 multiplied with the quotient of x squared, that's going to be 1 there. So 4 times 1 gives me 4. So place that 4 there, and the coefficient of x here is negative 5. So place that. Now you are expected to find two numbers. When multiplied you get 4, when added you get 5. So what would those numbers be? Now clearly if I were to place 4 and 1, 4 added with 1 would give me 5, but I need to get a negative 5. Of course 4 multiplied with 1 gives me 4. That's of course is valid, but negative 5 is only possible if I have a negative sign here and a negative sign here. So when you're writing it as a factor form, this is going to be x negative 4 times x negative 1 is equal to 0. From here, x negative 4 is equal to 0, x negative 1 is equal to 0, x is equal to 1, and x is equal to 4. So therefore the solution set would be 1 comma 4. So that is how we apply the factorization technique. Now let's do one more question. Question number 3. We are expected to solve x squared negative x negative 6 is equal to 0. As always, draw the wedge. Negative 6 times 1 is negative 6. The quotient of x is negative 1. So you're expected to find two numbers which when multiplied gives you negative 6 and which when added should give you negative 1. Now of course 3 and 2 would give you 6, but you need to get a negative 6 there, and when you add them they need to produce a negative 1. So if I were to have a negative 3 here, negative 3 added with positive 2 would give me negative 1. That's fair enough. And negative 3 multiplied with 2 would give me negative 6. So if you were to write them in factorized form, this should be the outcome. X negative 3 multiplied with x positive 2 is equal to 0. So from here this is going to be x negative 3 is equal to 0 and x positive 2 is equal to 0. So this is going to be x is equal to positive 3 and x is equal to negative 2. So therefore the solution set is going to be negative 2 comma 3. So that is going to be the solution for this question. Now next important concept we would have to focus here is the relationship between roots and coefficient. So the key word is roots and coefficients. Now let me just state this. If alpha and beta are the roots of this quadratic equation ax squared positive bx positive c is equal to 0, then we got two important concepts which we will have to know. Concept number 1 is called as the sum of roots, and that is given as follows. Alpha positive beta is equal to, since I just mentioned to you, the concept is called as relationship between roots and coefficient. So the formula is going to be alpha positive beta is equal to negative b over a, and the next important concept is called as product of roots. As I had mentioned to you, alpha and beta are the roots. So the first one is talking about the sum. The next one is the product, alpha times beta, which is equal to c over a. So this is the next important concept that you will have to write it down in the corner of your mind. So next we will look into some transformations in terms of alpha positive beta and alpha beta. So the first one that we will have to pay attention to is sum of squares. Alpha squared positive beta squared is equal to alpha positive beta raised to the power of 2 negative 2 times alpha beta. Number 2, alpha cubed positive beta cubed is equal to alpha positive beta raised to the power of 3 negative 3 times alpha beta times alpha positive beta. And alpha negative beta raised to the power of 2 is equal to alpha positive beta raised to the power of 2 negative 4 times alpha beta. Now we have seen the sum of roots. Now from formula 3 we can obtain the difference of roots. So have that in mind. Now 4 alpha raised to the power of 4 positive beta raised to the power of 4 is equal to alpha positive beta raised to the power of 2 negative 2 times alpha beta. Now this in turn has to be raised to the power of 2, followed by negative 2 times alpha squared beta squared. So these four important transformations are very important, and they play a very vital role in helping us solve questions of various difficulties. Now let us answer this question. Find the difference of roots. So as I mentioned to you while writing down the transformation, I said this particular formula can be used in achieving the difference of roots. So let's see how it is exactly obtained. So the question is, find the difference of roots. So we are asked to find what is alpha, negative, beta. Now let me consider this transformation. Consider alpha negative beta raised to the power of 2 is equal to alpha positive beta raised to the power of 2 negative 4 times alpha beta. Now we know that alpha positive beta is negative b over a and alpha beta is c over a. That's exactly what I'm going to be substituting here. So in place of alpha positive beta, I would place negative b over a raised to the power of 2 followed by 4 times of c over a. This can be rewritten as b squared negative 4c, and you have a denominator a squared here and a denominator a. Now let me multiply the numerator by a and the denominator by a. So this is rewritten as b squared over a squared negative 4ac divided by a squared. I take a squared as the common denominator, so this will give me b squared negative 4ac. On the left hand side I have got alpha negative beta raised to the power of 2. Now let me apply the square root quantity, square root function on both sides. So that would mean this would give me modulus of alpha negative beta, and this is going to be root of b squared negative 4ac divided by, since square root is a function, this will give me modulus of a. And this can be further rewritten by using capital D, because b squared negative 4ac is the discriminant. So just place that capital D divided by modulus of a. So this is going to be the difference of roots. And we will move on to the next concept. We are given this question, students. If alpha and beta be the two roots of x raised to the power of 2 negative 64x positive 256 is equal to 0, then we are expected to find the value of alpha cubed over beta raised to the power of 5. This is raised to the power of 1 over 8 positive beta cubed over alpha raised to the power of 5, and this entire quantity is raised to the power of 1 over 8. So this is required. So solution, we are given this quadratic equation. So let me write that down. Consider x to the power of 2 negative 64x positive 256 is equal to 0. Now from here, it's given that alpha and beta be the roots. So sum of the roots I'm taking. Alpha positive beta is going to be negative b over a. In this case is going to be negative of negative 64 divided by coefficient of x squared is 1. So you get alpha positive beta is 64 and alpha beta is c over a, which is nothing but 256. Now this is 64. Now can I write 64 as 2 raised to the power of 6? Yes? Okay. Now can I write 256 as, this is going to be 2 raised to the power of 8. Fair enough, right? Because 2 raised to the power of 6 means 2 multiplied 6 times. And that's going to give me 64. And if I were to, or if I need 256, I need to take 64 and multiply it by 4. So 4 4s are 16, 1, 24, 25, and that's nothing but 2 raised to the power of 8. Okay, so I've got these two acts together. Now let me just consider the given quantity. We are expected to find the value of this, right? So consider this is nothing but alpha raised to the power of 3 over 8 divided by beta raised to the power of 5 over 8 positive beta raised to the power of 3 over 8 divided by alpha raised to the power of 5 over 8, right? We expected to find the value of this quantity. Now let me take the LCM as alpha raised to the power of 5 over 8 times beta raised to the power of 5 over 8. Clearly beta raised to the power of 5 over 8 will get cancelled, will get neutralized by this quantity, giving me alpha raised to the power of 3 over 8 times alpha raised to the power of 5 over 8. So that's going to be alpha raised to the power of 1, followed by, similarly in this case, is going to be beta raised to the power of 1. So I've got alpha positive beta divided by alpha beta raised to the power of 5 over 8, right? Now alpha positive beta is 2 raised to the power of 6 and alpha beta is 2 raised to the power of 8. This is raised to the power of 5 over 8, so 8 and 8 gets cancelled, giving me 2 raised to the power of 6 over 2 raised to the power of 5, which is equal to 2. So that is the solution. So if they were to ask this question with the choices as A being 2, B being 3, C being 1 and D being 4, which one would you choose? This is the right answer to this question. Let's do this question, students. If alpha and beta are the roots of 2 times x of 2x positive 1 is equal to 1, then we are expected to find the value of beta. So this is critical. Now we have some choices. So the first choice is 2 times of alpha positive 1. Second choice is negative 2 times of alpha positive 1. The third choice is say alpha squared, and I think this is sufficient enough. For the objective is to know how to solve this question. Now the idea is to get the value of beta, but apparently the choices given here are in terms of alpha. So that would give us an indication that beta has to be represented in terms of alpha. So that is the first observation. Now let me start off the solution by considering the given system. So this is the equation given. So let me just write that down. Consider 2 times x of 2 times x positive 1 is equal to 1. I distribute 2x, so that's going to be 4 times x squared positive 2x negative 1 is equal to 0. So this is what we have got. Now from here, the sum of the roots alpha positive beta is negative b over a. So in this case going to be 2 over 4. It's negative 1 over 2. So this is a very important value that would come in handy. And the next thing is product of the roots alpha beta is c over a. So in this case it's going to be negative 1 over 4. Now if I were to cross multiply 2, I would get 2 times alpha positive 2 times beta is equal to negative 1. That's a very good system we have. Now having obtained this, let us go back to the original equation given. This is what is given. So we are given 2 times x of 2 times x positive 1 is equal to 1. This is given. Now clearly alpha is a root. Clearly, since alpha is a root, it means in place of x I would substitute alpha. So this would mean 2 times of alpha of 2 times of alpha positive 1 is equal to 1. And from here I can rewrite this as 4 times alpha squared positive 2 times alpha is equal to 1. So this is what I have got. Now I've got two systems here. I've got a system here, I've got a system here. So let me write this as 1 and write this as 3. So what we are going to do is we are going to be utilizing 3 in 1. But you might be asking, how are we going to do that? So there is a trick there. So from 1 I can write this as 2 times alpha positive 2 times beta is equal to, now I got a negative sign, I'm taking the negative sign out and writing it as negative of 1. Fair enough, right? But from 3 I've got 1 being equal to 4 alpha squared positive 2 times alpha. So that's exactly what I meant when I said I will be using 3 in 1. So this is going to be 2 times alpha positive 2 times beta is equal to negative, in place of 1 I will be substituting 4 times alpha squared positive 2 times alpha. Rewriting, this is going to give me 2 times alpha positive 2 times beta is equal to negative 4 times alpha squared negative 2 times alpha. I just retain beta here, 2 times beta here, and I move everything to the other side. So it's going to be negative 4 times alpha squared negative 2 alpha negative 2 alpha. This is going to be negative 4 times alpha squared negative 4 times alpha. Now if I were to take out negative 2 and alpha out, so this is going to give me, there's going to be a 2 there because 2 times 2 gives me 4, and there is one more quantity that we will have to take. Say I take alpha out, alpha is already taken out, so 2 into 2 would give me 4 there, minus alpha squared. Fair enough, that's fine. Now over here I need to have a negative sign, so I'll place a positive there, and that's going to be 2 there, right? So 2 alpha, negative 2 alpha with 2 alpha would give me 4 alpha squared, negative 2 alpha with positive 2 would give me negative 4 alpha. So over here I have 2 times beta, so I can clearly cancel the 2 out and have beta to be equal to negative alpha, right, of 2 times alpha positive 2. Now clearly you can see that I have a 2, I can simply take that 2 out. So if I were to take that 2 out, I would get negative 2 times alpha of alpha positive 1, right? So clearly the beta expression is negative 2 times alpha of alpha positive 1. So that is going to be the value of beta. Now let us go back to the choices. You can clearly see that this is the choice that has featured in our solution, right? So that is the end of the solution for this question. Let's do this question, students. We expected to find the product of the roots of the equation 9x squared negative 18 times modulus of x positive 5 is equal to 0. We given, say, 4 choices: 5 over 9, 25 over 81, 5 over 27, and d is 25 over 9. Now you have 9x squared and there is a modulus of x that is being featured there. So what I would like to do is, let me just write this down. Consider 9x squared negative 18 times modulus of x positive 5 is equal to 0. Now clearly x squared can be written as modulus of x raised to the power of 2. So I have this important equivalence in your mind, which is x squared is nothing but modulus of x raised to the power of 2. That's fair enough. So if I were to take this as 1, therefore I can rewrite 1 as 9 times modulus of x raised to the power of 2 followed by negative 18 times modulus of x positive 5 is equal to 0. Now this is actually a quadratic, right, in modulus of x. I have actually placed one more line there. So what I would do is I will have to somehow remove that. Okay, let me, so that's modulus of x there. So as I mentioned to you, this is a quadratic in modulus of x, and we can actually solve this by factorization technique. So 5 times 9 is 45, and I need to get a negative 18 there. Now 15 times 3 will give me 45, and 15 added with 3 would give me positive 18, but I need to have a negative 18 there, so I place negative sign. Negative into negative will give me positive 45, and when I add I get negative 18, so that's fair enough. So if I were to write this system down, then this system has to be written like this: 9 times modulus of x raised to the power of 2, and this has to be followed by, let me just place this negative 15 there, negative 15 into modulus of x, negative 3 into modulus of x. Negative 15 modulus of x added with negative 3 modulus of x would give me negative 18 modulus of x, followed by positive 5 is equal to 0. Now we need to be a little bit careful because of the fact that the coefficient of x squared is 9, right? So we had already studied how to solve questions with factorization technique, but in those questions we did not have the coefficient of x squared being featured as a quantity other than 1, and that is the reason now we are adopting this way of handling the system. Now what I will do is, clearly between 9 and 15 I will take out 3 modulus of x. If I were to do that, this is going to be 3 times of modulus of x followed by negative 5, right? 5 into 3 gives me 15 with a negative sign followed by modulus of x. Now over here I need to also have 3 into modulus of x followed by negative 1. So let me take a negative 1 out. If I were to take negative 1 out, this is going to be 3 into modulus of x. Negative 1 times 3 into modulus of x would give me negative 3 times modulus of x followed by a negative 5. You need to be a little bit careful in this way of representing things because of the presence of signs, and not only that, we have a modulus of x being present there. And let's move on. So taking 3 into modulus of x negative 5 as a common factor, we would get 3 times of modulus of x negative 1 is equal to 0. From here 3 times of modulus of x negative 5 is equal to 0, and you got 3 times of modulus of x negative 1 is equal to 0. From here 3 times of modulus of x is equal to 5. So modulus of x is equal to 5 over 3. Modulus of x is equal to 5 over 3. So let me just move on to this quantity. So this is going to give me 3 times of modulus of x is equal to 1, and modulus of x is equal to 1 over 3. Now modulus of x is equal to 5 over 3. We are expected to find the values of x. So x is going to be plus or minus 5 over 3. So 2 roots are there. Modulus of x is equal to 1 over 3. So x is going to be plus or minus 1 over 3. So another 2 roots are there. Now the question wants us to find the product of the roots. So that's exactly what we need to do. So we need to take the product of all the roots. So therefore product of the roots is equal to, I get 5 over 3 multiplied with negative 5 over 3. I get 1 over 3 multiplied with negative 1 over 3. So this is going to be negative, negative, positive. 5 5s are 25, 3 3s are 9, and then 3 3s are 9. 9 into 9 is 81, right? So this is the solution, 25 over 81. So where do we have that, right? Yeah, 25/81. So that's the solution for this question. Students, let's move on to the next one. Let's do this question. Students, we've been given that suppose A and B denote the distinct real roots of x squared positive 20x negative 2020, right? So this is a equation for which we got A and B being the real roots, and C and D denote the distinct complex roots of, say, x squared. This is positive, this is negative, followed by positive 2020. Now we are expected to find the value of A negative C times AC, positive AD times A negative D, positive BC times B negative C, positive BD times of B negative D. This is required. Now you've been given 4 choices. Choice A is 0, choice B is 8000, C is 8080, and choice D 16,000. So the question is straightforward. Let me just start off with the first equation. Consider x squared positive 20x negative 2020 equal to 0. Since A and B are the roots, so this would mean sum of the roots A positive B is equal to negative 20, and product of the roots is equal to C over A. So that's going to be negative 2020. Okay, now consider the other system. X squared negative 20x positive 2020 is equal to 0. Now from here, since C and D are the roots, complex roots in fact, okay, so this would mean C positive D is equal to 20 and CD is equal to 2020. So we got 2 important sums and 2 important products. Now we are expected to find the value. So consider the given system. I'm writing it in this fashion. AC of A negative C, positive AD of A negative D, positive BC of B negative C, positive BD of B negative D, right? Just distribute the quantities. AC times A, this is going to be A squared C, negative A times C squared, positive A squared D, negative A times D squared, B squared C, negative BC squared, positive B squared D, negative BD squared. This is what we have got. Now what I wish to do is I would have to club this with this, and I would get C positive D, that's fine. And then if I were to club, I got a B squared here. If I were to club with B squared here, okay, I can club these two together. So B squared is taken out, C and D would be there, and what else? I have a BD squared, negative BD squared, that wouldn't come in much handy for us. And I got BC squared, and okay, I can club these two together, right? So I take a negative sign out, I take a c squared out, so I would get a positive b, right? Fair enough. So that's done. And what else remains? So I've got a AD squared and negative BD squared. So if I were to take a negative, if I were to club this with this and this, I would have a positive b out, right? So this is what I have got. So I've taken care of this and this. This is also done. This is done. This is done. And this is done. And everything is exhausted. That's fine. Now all that remains is to substitute the values for c positive d, which is 20. And 20. And then for a positive b, which is minus 20 and negative 20. So this is going to be equal to 20, 20, 20, 20. I can take 20 out. This would give me a squared positive b squared, negative, negative, positive, c squared, positive d squared. Now 20 is there. I can write a positive b, in fact a squared positive b squared as a positive b raised to the power of 2, followed by negative 2ab. Similarly, c squared positive d squared, I can write it as c positive d raised to the power of 2, negative 2 times cd. So this is equal to 20 times. Now a positive b is 20, right? Negative 20 raised to the power of 2, negative 2 times ab is negative 20, 20, positive c positive d is 20 squared, negative 2 times cd, cd is 20, 20. Okay, fair enough. Now negative, negative, positive, and you got 2 times of 20, 20, right? So this is negative, this is positive, so they both gets cancelled off. And what have we got? We got 20 times of this 400, and then you got 400. This is 20 times of 800, which is equal to 0, 0, 0, 16. So this is the value. 16,000 is the value. So where do we have it? Let's go and check out the choices. You see that these are the choices, and clearly 16,000 is waving at us. So that is the solution for this question. Students, will go on to the next one. Students, this is another important concept that we will have to know, which is formation of quadratic equation from the roots. And the form of the quadratic equation is given to be in this fashion: x squared negative of alpha positive beta times x positive alpha into beta. So this is the form that we will have to use if we are given the roots and we are expected to obtain the quadratic equation. Now let me give you an example. So this is an example. Now in this example we are expected to form the quadratic equation if 5 and negative 2 are its roots. So we got alpha to be as say 5 and beta is negative 2. So therefore sum of the roots alpha positive beta is 5 added with negative 2, which is going to be equal to 3, and the product of the roots is 5 times of negative 2, which is equal to negative 10. Now we are going to be using this system, so therefore the form of the quadratic equation is going to be x squared negative Sum of the roots, alpha positive beta is 3, place that and place the variable x, followed by the product of the roots alpha into beta is negative 10. So if you were to rewrite this, you would get x squared negative 3x negative 10. So this is the quadratic equation that is formed. In fact, since it is an equation, we will have to equate it to 0. Probably we can state the solution. Therefore, the required quadratic equation is x squared negative 3x negative 10 is equal to 0. So that is the solution for this question. Now let me just do one more question. Form an quadratic equation given that 2 and negative 1 over 2 are its roots. Okay, so this is a simple question. So we have got alpha is equal to 2 and beta is equal to negative 1 over 2. So I'm taking the sum of the roots. Alpha positive beta is 2 added with negative 1 over 2. So that's going to be 4 negative 1 over 2, which is 3 over 2. And the product of the roots alpha beta is 2 times of negative 1 over 2, which is negative 1. So therefore the required quadratic equation is of the form x squared negative of alpha positive beta times x positive alpha into beta is equal to 0. So this is the required that we are aiming at. So we now have x squared negative of alpha added with beta is 3 over 2 times x positive of negative 1, which can be rewritten as, so you got this 2 here, so I'm going to multiply it throughout by 2. So this would give me 2 times x squared negative 3x, and since I'm multiplying by 2, this is going to give me negative 2 is equal to 0. So this is the required quadratic equation. So I hope you understood this concept, students, and I'm sure you will be able to handle other questions also of this fashion. Let's do this question, students. Find the quadratic equation with rational coefficients and it is given that which as 1 over 3 positive 2 times root 2 as a root, right? So this is one root. Apparently we have been given the root to be in this fashion, so we need to rationalize this. So solution, let alpha be that root 1 over 3 positive 2 times root 2. I will rationalize it by multiplying the numerator by 3 negative 2 times root 2 divided by 3 negative 2 times root 2. This is going to be 3 negative 2 times of root 2 divided by 3 squared negative 2 squared, and the root 2 into root 2 would give me 2. So this is going to be 3 negative 2 times of root 2 divided by 3 squared is 9, 2 squared is 4, 4 times 2 is 8. So 3 negative 2 times root 2 is my alpha. Now since we are dealing with the root of this fashion, the obvious root, therefore beta is going to be, if this is going to be 3 negative 2 times root 2, my other root beta is going to be the conjugate of this. So it's going to be 3 positive 2 times root 2, and that's the way the roots work in this fashion. So we got the alpha and we got the beta, so therefore alpha positive beta, we need to take the sum. So 3 negative 2 times root 2 added with 3 positive 2 times root 2, negative positive gets cancelled, giving me 3 added with 3, which is going to be 6, and the product of the roots 3 negative 2 times root 2 multiplied with 3 positive 2 times root 2, this is going to give me 3 squared negative 2 squared and 2, 9 negative 8, which is going to give me 1. So therefore the quadratic equation is going to be x squared negative of alpha positive beta times x positive alpha into beta is equal to 0. So this is the required quadratic equation. So if I were to write the values, x squared negative of alpha added with beta gives me 6 followed by an x, and alpha into beta gives me 1, which I need to just simply place here and then equate it to 0. So this is the final solution for this particular question. Let us wrap this section on obtaining the quadratic equation from the roots with this question. So the question is, find the quadratic equation given that negative 2 positive I being one of its roots. Okay, now you should know that whenever you're talking about complex roots, they occur in conjugate pairs. So let alpha be equal to negative 2 positive I be the root, and the other root beta is going to be the exact conjugate for this. So it's going to be negative 2 negative I. So this is the root for beta. So therefore clearly you can sum it up. So alpha positive beta is going to be negative 2 positive I, negative 2 negative I, positive I negative I gets cancelled, giving me negative 4, and alpha times beta, which is going to be negative 2 positive I being multiplied with negative 2 negative I. So this is going to give me negative 2 squared, positive negative negative, and I squared. So this is going to be 4 minus I squared is going to be negative 1. So when you add up, you get 5. So the quadratic equation, therefore if you were to write the quadratic equation, this is going to be of the form x squared negative of alpha positive beta times x positive alpha beta is equal to 0. So this is the quadratic equation. In this case, alpha added with beta is producing me negative 4. So I need to place the value over here, negative 4. So let us do that. So minus 4 times x, alpha beta is going to give me 5, which can be rewritten as x squared positive 4x positive 5 is equal to 0. So this is the required quadratic equation for this particular question. Now you can literally check this out, you know. So if I were to use the quadratic formula, let me show you that to you. My b is 4 here, but it's negative b, right? So it's negative 4 plus or minus root of b squared is 16, negative 4 5s are 20 divided by 2. So if you were to solve this, this is going to give me negative 4, right, which can be rewritten as 4i squared. So if you were to take the root of it, this is going to be 2i plus or minus, this is going to be negative 4 divided by 2. So if you were to reduce the roots, let me use this space here. So this is going to give me negative 2 followed by positive I, that's going to be one root for the positive side. So for the negative side, negative 2 negative I divided by 2, right? I mean negative 2i divided by 2, and that's would obviously will get reduced because of the presence of the 2 in the denominator. So clearly you can see that these are the roots that we have produced. See, negative 2 positive I is one of the roots given. Obviously we have extracted the other root, negative 2 negative I, and that is how we extract the roots given the quadratic equation. So that completes this section on our study, students. We'll move on to the next one. Now students, the next concept we will be looking up into is what is called as the Newton's method, and it is also called as the power of roots, right? Now the word itself suggests it's a power of roots, and so far we've been only looking into a root of this fashion, either alpha positive beta or alpha negative beta, right? So there isn't any powers attached to alpha or to beta. But in Newton's method, we will be talking about or dealing with questions where the power is also attached to the root. So that is an interesting concept. So how the statement of the Newton's method is presented, and let me give you that. So let alpha and beta be the roots of a quadratic equation, And let that quadratic equation be of the form ax squared positive bx positive c is equal to 0. And we have a relationship s suffix n is equal to alpha raised to the power of n plus or minus beta raised to the power of n. Now if this is the system that is given, then this will always be true. So that statement is presented as follows. So what is that statement? Now we start with a. Whenever you see x squared, you replace it by s suffix n, and since the degree of x is reduced here, you replace it by s suffix n minus 1. And for c, what you need to do is you need to replace it by s suffix n minus 2, and this is equated to 0. So remember, x squared is replaced as s suffix n, x is replaced as s suffix n minus 1, and c is replaced by s suffix n minus 2. So this is the relationship that is provided by Newton's method, and this is equal to 0. Now the best way, as I always mention to you all, is to do questions. So as you progress doing questions, you will be in a better position to understand this particular method. So let's do that. Let's do a question, students, that has some application connected to the concept we just studied. So let me write the question down. Let alpha and beta be the roots of x squared negative 6x negative 2 is equal to 0 with alpha greater than beta. This is given if a suffix n, instead of s suffix n, they are using a suffix n. If a suffix n is alpha raised to the power of n negative beta raised to the power of n, instead of positive they are giving as a negative difference, right? And if this is given, of course, for n greater than or equal to 1, then they are asking us to find the value of a suffix 10 negative 2 times a suffix 8 divided by 2 times a suffix 9. We need to extract this value. This is straightforward. So consider x squared negative 6x negative 2 is equal to 0. Now by applying Newton's method, we can rewrite this as, in place of s suffix n we got a suffix n. So x squared will be replaced with a suffix n followed by negative 6 times a suffix n minus 1, negative in place of the constant term, or I should say there is a c there, so that c is actually replaced with a suffix n minus 2. So constant still stays there, and this is equated to 0. Now we expected to find the value for a suffix 10 negative 2 times a suffix 8 divided by 2 times a suffix 9. So for that I'm going to take the value of n to be as 10. Let n be equal to 10. So this is going to be a 10 negative 6 times a suffix 9 negative 2 times a suffix 8 is equal to 0. I will retain these two together. So this is equal to a suffix 10 negative 2 times a suffix 8 is equal to, I'm going to push this to the other side, so 6 times a suffix 9. Now since the quantity is divided by 2 times a suffix 9, let me divide this also by 2 times a suffix 9, 2 times a suffix 9. Clearly a suffix 9 gets cancelled. 2 divides 6 3 times. So therefore we have obtained the value for a suffix 10 negative 2 times a suffix 8 divided by 2 times a suffix 9 to be as 3. So this is the final solution for this particular question. Let's do another question, students. Let alpha and beta be the roots of this equation. 5x squared positive 6x negative 2 is equal to 0, and s suffix n is equal to alpha raised to the power of n positive beta raised to the power of n, with n being equal to 1, 2, 3, etc. Then one of the following is said to be true. So So the choices are A, is it 6 times s suffix 6, positive 5 times s suffix 5 is equal to 2 times s suffix 4. B, is it 6 times s suffix 6, positive 5 times s suffix 5, positive 2 times s suffix 4 is equal to 0. Or C, 5 times s suffix 6, positive 6 times s suffix 5 is equal to 2 times s suffix 4. So one of the listed choices should be the solution for this question. So let me just give you the solution. So I start off by consider 5 times x squared positive 6x negative 2 is equal to 0. So this is what is given. Now by applying Newton's method, what happens? This can be rewritten as 5 times. In place of x squared, I'm going to write it as s suffix n, positive 6 times s suffix n minus 1, negative 2 times s suffix n minus 2 is equal to 0. Now clearly you can see the choices are s6 there. So let me take n to be equal to 6. If that be the situation, I will now have 5 times s suffix 6, positive 6 times s suffix 6 minus 1, 5, negative 2 times 6 minus 2, that's going to be 4, is equal to 0. Now this can be further rewritten as 5 times s suffix 6, positive 6 times s suffix 5 is equal to 2 times s suffix 4. Now compare the choices. Clearly you can see that C is the right solution for this particular question. Okay students, now I will prove the Newton's method. Okay, so over here we are going to prove it. Given that alpha comma beta being the roots of a quadratic equation, say ax squared positive bx positive c is equal to 0, and that s suffix n is equal to alpha raised to the power of n positive beta raised to the power of n. It can also be negative, but I'm just taking the positive side. Okay, then by Newton's method, a times s suffix n, positive b times s suffix n minus 1, positive c times s suffix n minus 2 is equal to 0. So this is the proof I'm going to arrive at. Now let me start. Consider, this is the start of the proof, consider the given quadratic equation ax squared positive bx positive c is equal to 0. Since alpha is a root of 1, if I were to take this as 1, then this would mean I can now rewrite this as alpha times, in place of x I'm going to substitute alpha, right? So this is going to be alpha squared times a positive beta times alpha positive c is equal to 0. So this is what we have got. Also beta is a root of 1. So this means a times beta squared positive b times beta positive c is equal to 0. So you have two systems right over there. Now what I would like to do is, let me take this as 2, let me take this as 3. Now I would like to multiply 2 by alpha raised to the power of n minus 2. Right, so if I were to multiply it with alpha raised to the power n minus 2, the first term would be obtained as alpha raised to the power of n. So that will be the first term that we would be getting at. So let me multiply 2 with alpha raised to the power of n. In fact, I will have to neutralize this 2. So what I will do is I will multiply it by alpha raised to the power of n minus 2. Right, so therefore my 2 is going to be, so this is what I've got, a times alpha squared positive b times alpha positive c is equal to 0. I'm going to be multiplying this by alpha raised to the power of n minus 2, because n minus 2 and positive 2, they get cancelled. So this is going to give me a times alpha raised to the power of n, positive b times alpha raised to the power of n minus 1, positive c times alpha raised to the power of n minus 2 is equal to 0. Now 3, I'm going to multiply 3 by beta raised to the power of n minus 2. Right, so that would be giving us the following. So beta raised to the power of n minus 2 times, so this is actually a and b. Okay, all right. So a times beta squared positive b times beta positive c is equal to 0. So this can be rewritten as, in place of beta squared times beta n minus 1 n minus 2, we would now have a times beta raised to the power of n, positive b times beta raised to the power of n minus 1, positive c times beta raised to the power of n minus 2 is equal to 0. So this is what we have got. Now if I were to add these two together, I would get a of alpha raised to the power of n, positive beta raised to the power of n, positive b times of alpha raised to the power of n minus 1, positive beta raised to the power of n minus 1, positive c times of alpha raised to the power of n minus 2, positive beta raised to the power of n minus 2 is equal to 0. Now let me just direct your observation to s suffix n. S suffix n is alpha raised to the power of n, positive beta raised to the power of n. So this is going to be s suffix n, positive b times s suffix n is alpha raised to the power of n, positive beta raised to the power of n. Therefore s suffix n minus 1 is going to be alpha raised to the power of n minus 1, positive beta raised to the power of n minus 1. So that's the reason I'm getting s suffix n minus 1 followed by c times of s suffix n minus 2 is equal to 0. So this is exactly what we have achieved, or in other words what we ought to achieve. So that is exactly the corresponding Newton's method which we started off to prove, and we have proved. So hence proved. Let's do this question, students. Let p and q be integers and let alpha comma beta be the roots of the quadratic equation x squared negative x negative 1 is equal to 0 with alpha not equal to beta. So the roots are distinct. Now for n equal to 1, 2, 3, etc. In fact it starts with 0, 0, 1, 2, 3, etc. We are given that a suffix n is equal to p times alpha raised to the power of n, positive q times beta raised to the power of n. And the question has got two parts. The first part, the question wants us to find what is a suffix 12, and for the second part, little bit work is involved to answer the second part. It says if a4 is equal to 28, find the value of p positive to q. Right? Now there are a few set of choices given for the first part. The choices are listed as follows. Is it A11 negative A10? B, is it A11 positive A10? C, is it 2 times A11 positive A10? So I'm just giving you three choices for the first part. For the second part, is it 21? Is it 14? Is it 12? So you will have to pick out the right choice. So as I mentioned to you, the question has got two parts. Part 1 is this, we are expected to find A12. Part 2, we are given that A4 is equal to 28 and we are expected to find the value of p positive to q. Now let me just do the first part. Now we are given this. Consider x squared negative x negative 1 is equal to 0 by Newton's method, we know that I can rewrite x squared as a suffix n, because we are given a suffix n to be as p times alpha raised to the power of n positive q times beta raised to the power of n. So that's why I'm using a n. Instead of a n, if they would have given us s n, I would have used s n. So this is going to be a n negative a n minus 1 negative a n minus 2 is equal to 0. Now we expected to find a12, so let me just retain a n on this side and move the other quantity to the other side. So there's going to be a n minus 1 positive a n minus 2. Now, as I mentioned to you, they want us to get a12. When n is equal to 12, this, if I were to take this as 1, therefore 1 can be rewritten as a12 is equal to 12 minus 1, 11, positive 12 minus 2, that's going to be a10. So this is the value for a suffix 12. Now pick out the choices that are being given here. Which of the choices you think is matching for a12? Clearly I can see a12 value being featuring here, a11, positive a10. So B is the right choice for this particular question. Now we are expected to obtain the solution for part 2. Now it says that if a4 is 28, we are expected to find the value of p positive 2q. Now when n is equal to 4, therefore I can rewrite 1 to be as a4 is equal to a3 positive n is equal to 4, so this is going to be a2. Now what I want to do is I want to rewrite a2 by substituting n is equal to 2. So if actually it is not n is equal to 2, it is n is equal to 3. So because we are trying to obtain the value for a3. Now if n is equal to 3, therefore 1 can be rewritten as a3 is equal to a2 positive a1, right? So this is the representation for a3. So let me substitute that. So it's going to be a2 positive a1 positive a2. On the left we've got a4. Now when n is equal to 2, 1 can be rewritten as, I take the value of 2 and place it here. This is going to give me a2 and this is a1 positive a0. So take the value for a2 and substitute it here. So this is a1 positive a0 positive a1 positive a1 positive a0. So add up these quantities. You got a a1 and a a1. So 3a1 a0 and a0, 2 a0. So on the left you got a4. Now we also have the relationship given in terms of pq, alpha n, beta n and a n, right? So we know that, let me write that down. We are given that, right? So we know that a suffix n is equal to p times alpha raised to the power of n positive q times beta raised to the power of n. Now if I were to take when n is equal to 1, this is going to be a1 is equal to p times alpha 1 positive q times beta 1, which is nothing but p times alpha positive q times beta. So this is for a1. Now when n is equal to 0, what happens? a0 is equal to p times alpha raised to the power of 0 positive q times beta raised to the power of 0. This is nothing but p positive q. So this is for a0. So I got a0 and a1. Now let me take this as say 2. So therefore I can rewrite 2 to be as a4 is equal to 3 times, in place of a1 I'm going to substitute p times alpha positive q times beta positive 2 times, in place of a0 I'm going to substitute p positive q. So this is what we have got. Now we got alpha and beta, but from the question we know that alpha comma beta are the roots of the given quadratic, which is x squared negative x negative 1 is equal to 0, right? This is exactly what has been given in the question. It says alpha beta being the roots of this quadratic equation. So we would be using that fact. So that means if I were to apply quadratic formula and extract the roots, that would give me x being equal to -1, negative of -1, that's going to be +1, plus or minus root of 1, -4 times a times c is -1 divided by 2. So this is going to be 1 plus or minus root of 1 followed by negative, or negative is positive, so it's going to be 5 there. So therefore the roots would be alpha being equal to 1 positive root 5 divided by 2 and beta being equal to 1 negative root 5 divided by 2. So if I were to take this as 3, I would be utilizing these values in 3. So therefore 3 can now be rewritten as A4 is equal to 3 times of p times of alpha value 1 positive root 5 divided by 2 positive q times beta value 1 negative root 5 divided by 2 positive 2 times of p positive q. Now clearly you can see root 5 is an irrational quantity. So what I would do is I would like to write the quantities as a rational quantity, positive and irrational quantity. So this can be rewritten as 3 times p. So let me split this in this following fashion. So p times 1 positive p times of root 5, and I've got a 2 here and a 2 here, followed by q over 2 negative q times of root 5 over 2 positive 2 times of p positive q. So this is rational, this is rational, this is irrational, this is irrational. So we can actually split these quantities as I mentioned to you, rational, positive, irrational quantity. So this is going to be 3 times of p over 2 positive q over 2 and followed by 2 times of p positive q. So this entire thing is a rational quantity followed by 3 times of irrational quantity is going to be p times of root 5 divided by 2 negative q times of root 5 divided by 2. Now A4 is given to be as 28. So this is a rational quantity and you got 0. I'm placing 0 because just to symbolize that irrational quantity is missing. So you got a rational quantity plus an irrational quantity, which is 0 here, and that is equated to a rational quantity, positive and irrational quantity. So equating we get, so what do we get? On the left hand side you get 0, on the right hand side it's going to be 3 times of p times root 5 over 2 negative 3 times q of root 5 over 2. So if you were to push it to the other side, you would get this to be as 3 times p times root 5 divided by 2 is equal to 3 times q times root 5 divided by 2. 2 can be cancelled, 3 can be cancelled, root 5 can be cancelled, giving me p is equal to q. So this is one of the important equation we have obtained because of equating the irrational parts. So now taking this information and placing it in the rational part. So foremost what we will do is we will equate the rational part with 28. So 28 is equal to 3 times of p. In fact, we have got p is equal to q, so we can very well utilize that. So 3 times of, so I will just retain p as it is, but for q I will substitute p, right, followed by 2 times of p positive p. So this is what we have got. This is equal to 3 times of, if I were to take 2 as the LCM, this would give me 2 times p followed by 2 times of 2 times p. 2 can be cancelled, giving me 3 times p positive 2 2's are 4p, which is nothing but 7p. On the left side it's 28, so therefore p is equal to 4. So p is equal to 4, which means q is equal to 4 because p is equal to q, right? So we have got that value. But actually, what does the question wants? The question wants us, if we were to move up and see the question wants us to find the value of p positive 2q. So therefore, okay, probably I will just write that down. So therefore, p positive 2q is nothing but p is 4 and q is 4. This is 4 positive, 2 times 4 is 8. 4 added with 8 would give me 12. So this is the solution, and that should be one of the choices that we are looking for. So clearly you can see that A is 21, B is 14, and C is 12. So this is the right solution for this question. This is a beautiful problem, students. I hope you enjoyed this, and we will move on to the next question. Students, the next important concept that we would be looking into is called as the nature of roots. Now we know that the formula of a quadratic equation is given as x is equal to negative b plus or minus square root of b squared negative 4ac divided by 2 times a, where ax squared positive bx positive c is equal to 0 is the quadratic equation under question. And this quantity b squared negative 4ac is called the discriminant, and this is the quantity that is largely responsible for determining the type of roots that a quadratic equation can have. So having mentioned this, it is also represented with a capital D, b squared negative 4ac. So there are a few choices, or I should say a few criteria that D takes. The first criteria is that now if D is greater than 0, the value of b squared negative 4ac, if it is greater than 0, then the roots are real and distinct. So this will be the outcome. Number 2, if D is equal to 0, then the roots are real and equal. Finally, if D is less than 0, then the roots are complex. So this is a very important concept that would be used in solving quadratic equation when it comes to determining the nature of roots. Now there are other few important points that you will have to know. If the coefficient of the quadratic equation are rational, have this in mind, if the coefficient of the quadratic equation are rational, then its irrational roots always occur in pair. So this is a very important concept. So if the quadratic equation has been found to have a irrational root, then obviously the other irrational root can easily be obtained owing to the fact that irrational roots in a quadratic equation, they occur in pairs. So the exact understanding is, if say p positive root of q is an irrational root for the quadratic equation, clearly you can see that this is an irrational root, p positive root of q, right? Then p negative root q will also be a root. So have this in mind. If p positive root q is an irrational root, then by default p negative root q will also be a root of the required or the concerned quadratic equation. So point number 2, if the coefficients of its coefficients, right, if the coefficients of the quadratic equation are real and it is found that the quadratic equation has a complex root, then the other root will be a complex conjugate of the root So what is the meaning of this? Say if P positive IQ is a root of the quadratic equation, then the other root is going to be the complex conjugate of this. Then obviously P negative IQ will also be a root. So that is the important understanding that we need to gather here. So these are some of the important concepts that is imperative that we have it in the corner of our minds, so that when it comes to problem solving, we will be able to handle these problems with ease. Let's do this question, students. We've been given that the quadratic equation with rational coefficient whose one root is 2 positive root 3 is what? So they're asking us to find the quadratic equation, and the information given is that one of the roots being of the form 2 positive root 3. So let me give you the solution here. Since we know that irrational roots occur in pairs, this means 2 negative root of 3 will also be a root of the quadratic equation. So this would mean if alpha is equal to 2 positive root 3 and beta is equal to 2 negative root 3, then sum of the roots alpha positive beta is going to be 2 positive root 3 positive 2 negative root 3. Negative root 3 positive root 3 cancels off, giving us 4, and the product of the roots alpha beta is going to be 2 positive root 3 multiplied with 2 negative root 3. So this is going to be 2 squared negative root 3 squared, which is 4 negative 3, which is equal to 1. So therefore the required quadratic equation is going to be x squared negative sum of the roots positive product of the roots, and this is going to be the required quadratic equation. So this can be rewritten as x squared negative sum of the roots is going to be I need to place the x there, so it's going to be x squared negative 4 times x positive 1 is equal to 0. So this is the solution, or I should say the required quadratic equation that is expected from this question. Let's do this question, students. If 2 positive I times root 3 is a root of the quadratic equation x squared positive px positive q is equal to 0, where p comma q are real, and we are expected to find p and q such that one of the given relationships is said to be true. So the choices are p squared negative 4 times q positive 12 is equal to 0, q squared negative 4 times p negative 16 is equal to 0, c q squared positive 4 times p positive 14 is equal to 0, and finally you got p squared negative 4 times q negative 12 is equal to 0. So the understanding is, after we have extracted the value of p and q, upon substituting the value for p and q, one of the system is said to be true. In other words, upon substituting the value of p and q, we will equate or get the outcome to be equal to 0. So that is the understanding. The left hand side will become equal to right hand side. Now the main point is, we need to extract the value of p and q, right? So the information that we've been given here is 2 positive I times root 3 is the root of the quadratic equation. Now we know that complex roots occur in conjugate pairs. Complex roots occur in conjugate pairs. Conjugate, okay, this is G-A-T-E, okay, conjugate pairs. So this is the very important statement. So this would mean 2 negative I times root 3 is also a root. So if I were to take alpha to be as 2 positive I times root 3, then alpha positive beta is going to be 2 negative I times root 3. So clearly I root 3 negative I root 3 gets cancelled, giving us 4, alpha positive beta being equal to 4. Now the product of the roots alpha beta is going to be 2 positive I times root 3 multiplied with 2 negative I times root 3. So this is complex multiplication. So this is going to give me 2 squared negative I square times root of 3 raised to the power of 2. So that's going to be positive 3, right? So this is going to be 4 positive 3, which is nothing but 7. So this is the value that we get when you multiply the roots, the product of the roots. Now we have to substitute it in the given quadratic equation. So therefore the quadratic equation is what? X squared negative of sum of the roots, and that sum of the root is going to be 4 there, positive product of the roots is 7 is equal to 0. So this would mean you have now the quadratic equation to be x squared negative 4 times x positive 7 is equal to 0. Now we have to compare this to the quadratic equation that is being given to us, x squared positive px positive q is equal to 0. So upon comparing, what do we get? This would mean my p is negative 4 and my q is 7. So after we have got the value of p and q, you need to take the value back and substitute it in the given equation that you see here. So you got 4 of these equations. Now if you were to substitute in the first equation, say p squared, let me show that to you here. P is negative 4, square it up, you get 16, and q is 7, 7 times 4 is 28, so 16 negative 28, that is going to give me a value of negative 12, right? Negative 12. When you add 16 with negative 28, this is the outcome you get, but there is already a positive 12, so that means 0 is equal to 0. So this is what we are actually looking forward to. Now if you were to take the value of p and q, you are not going to get any of these things to be satisfying. You can try that out. Say q, in this case if I take q is 7 sevens are 49 negative, p is 4, so it's going to be 4 4s are 16. You see that 49 and 16, that is not going to give us the value 0. So all of these things will fail except for the choice A. So that is the end of this particular question. Let's do this question, students. We are expected to find the number of all possible positive integral values of alpha such that the roots of the quadratic equation 6x squared negative 11x positive alpha equal to 0 are rational. So we expected to find the values of alpha, integral values of alpha, for which the quadratic equation has rational roots. So the condition, so let me give the solution here. The condition for the quadratic equation to have rational roots is that the discriminant should be a perfect square. So this is what has to be achieved. Now, when exactly will the discriminant be perfect square? That is where we have to make the choices of alpha. Of course, this question is just a logical question, and to solve this we need to use guess and check. So let me start off with considering the given quadratic equation. Consider the quadratic equation 6x squared negative 11x positive alpha is equal to 0. So from here, let me obtain the discriminant. I don't need to obtain the value of the roots. I need to just find the discriminant. So discriminant for this is b squared negative 4ac. So what is that? My b is negative 11 squared negative 4 times, a is 6, and my alpha has to be retained as it is. So this is going to be 121 negative 6 times 4 is 24 times alpha. Now if I were to apply the square root, I need to get a perfect square. That is the simple logic that we are looking for here. Now we can take the values of alpha, right? So we can start. Alpha is actually positive integral value, so that is the important thing. Find the number of all possible positive integral value. That means we cannot take alpha to be equal to 0. So the first value is going to be 1, and 2, 3, 4, 5, 6. So let's check out these values. Now when alpha is equal to 1, what happens? It's going to be 121 negative 24, and this is for alpha is equal to 1. Now let me just take alpha is equal to 2. This is 121 negative 48. This is when alpha is equal to 2, and alpha is equal to 3. 121 negative 3 4s are 12, 1 3 are 3 2 are 6, 72. This is alpha is equal to 3, and alpha is equal to 4. 121 negative 4 4s are 16, 1 4 2s are 8, 96. Alpha is equal to 4. Alpha is equal to 5. 121 negative 5 4s are 22, 5 2s are 10, 11, 12. So that's alpha is equal to 5. Alpha is equal to 6. 121 negative 6 4s are 24, 2 6 2s are 12, 13, 14. So this will become negative. So alpha is equal to 6 has to be dropped. Now let me evaluate 141 negative, it's actually 121 negative 24. Let me subtract that and check if we are getting any perfect squares. So this is going to be 7, and this is right away ruled out because of the fact that this is ending with 7. So this alpha is equal to 1 has to be dropped. Now next, 121 and 48, this is going to give me 3, 8, 9, 10, 11, 3. So this is also ruled out. This is not going to give us a perfect square. Now followed by 121 and 72. So this is going to be 9. I have 7 and 8, 9, 10, 11, 49. Yes, alpha is equal to 3 root of 49. This is a perfect square. And alpha is equal to 4. Let's check that out. 121 and 96. I get a 5, 11, 9, 10, 11, 25. Yes, so this is root of 25. This is a perfect square, and in this case alpha is equal to 5. This is going to give me root of 1. So this is also okay. So what are the values? What are the integral values? If they're asking us to find the integral values, alpha is equal to 3, 4 and 5, and that should be the solution. So if they give you a choice, say for example, if they are asking us to find the number of such alpha, so in this case you can see that find the number of all possible positive integral values of alpha. So we have been given a choice. Imagine a choice is being given to us. Say A is 3, B is 2, and C is 4, and D is 5. Right? So we got choices like this. Now clearly this is going to be the right solution for this question, because we have found 3 such integral values of alpha for which we are getting a rational root, and that is the end for this particular question. Welcome students, we are given this question. Let me write the question down first. The roots of the quadratic equation x squared negative of 2 times of a positive b times x positive 2 times of a squared positive b squared is equal to, we've been given the following choices. So they are asking us to naturally find out the nature of the roots. So the first one is, are they rational and different? And choice number 2 is, are they rational and equal? Choice number C is, are they irrational and different? And choice number D is it complex? So we got several of these choices, but all of these choices would depend upon the value of the discriminant. So if the discriminant is a perfect square, then the roots would be rational. That is the basic part, okay, because it's a perfect square. And if it is negative, it will become imaginary. In other words, it's complex, it's going to be complex. And if it isn't a perfect square, then it would be an irrational quantity. So, and this rational and equal, right, that is a case when the discriminant becomes equal to 0. So everything depends on the value of D. That's exactly what we need to find out. So let me just calculate the D value. In this case it's b squared, so negative 2 of a positive b raised to the power of 2. Negative a is 1 and c is 2 times of a squared positive b squared. So this is what we've got. Now if you were to square this, you get 4 times of a positive b raised to the power of 2, negative 4 times of 2 times of a squared positive b squared. If you were to take 4 out, this is going to be a positive b raised to the power of 2, negative 2 times of a squared positive b squared. If you were to expand this, you get a squared positive 2 times ab positive b squared, negative 2 times a squared, negative 2 times b squared. This is what you get. So this can be further rewritten by adding a squared with negative 2a squared, that's going to be a squared. B squared with negative 2b squared, that's going to be negative b squared and followed by 2 times ab. So if I were to take the negative sign out, this is going to be a squared positive b squared negative 2 times ab, which is nothing but negative 4 times of a negative b raised to the power of 2. This is a perfect square, but you got a negative value. So that would mean, this would mean the roots are complex. Right? Sometimes instead of using the term complex, they will use the term imaginary. So you need to be prepared. So when it is complex, it means it's by default it carries an imaginary part. So that is the choice. The choice is D for this particular question. Let's move on to the next question. Students, the next concept that we will be looking into is graphs of quadratic equation. Now, I already mentioned to you at the start of the class that graphing a quadratic equation is also one of the ways by which we can solve a quadratic equation. Now, the graph of a quadratic equation is a very important point that you will have to take note of. The graph is, let me write that down. The graph of a quadratic equation is always a parabola. But the condition here is it might either open upward or downward. So these are the two varieties that we will be talking about. Now, if a is greater than 0, it is a U-shaped parabola. U-shaped parabola. So when I talk about a greater than 0, I am talking about a quadratic equation of the form ax squared positive bx positive c. So this is what I am referring to. And this is the first case. The second case scenario is if a is less than 0, then it is inverted U. Inverted U-shaped parabola. So these are the two varieties that we will be looking in. And the next important thing that we need to know is the coordinates. Coordinates of the vertex. So because to draw this, you need to have a vertex, right? The vertex has to be located. So how are we going to locate the vertex? That is given by this particular coordinate formula. Negative b over 2 times a, comma negative d divided by 4a. So this is standard. This is not going to change at all to locate the coordinates of the vertex. So this is point number 2. And point number 3 is the parabola intersects the y-axis at the point 0, c. Right? Say for example, you are taking y is equal to ax squared positive bx positive c. For the parabola to intersect y-axis, we have to take x is equal to 0, right? That is the natural choice for the value of x. So if we were to take the value of x to be equal to 0, definitely in this case, we take x is equal to 0. The only value that is alive here would be c. So y is equal to c. So therefore 0, c would be the point where the parabola intersects the y-axis. So these are some of the important knowledge points that you will have to have when it comes to graphing a quadratic equation. The next important point is determining the real roots. This is very critical. Now, how are we going to determine the real roots? Now, this is obtained by finding the number of times the graph intersects the x-axis. So that is the concept that would be applied to find the number of real roots. So in other words, imagine you have a graph like this. In this case, the number of, this is the x-axis and this is the y-axis. The number of intersection that the graph does with the x-axis is 2. So the number of real roots is going to be 2 in this case. And if you were to look into the discriminant would be greater than 0 here. Have this in mind. So this is one of the cases you will have to know. Now case number 2, if the graph is actually hitting the x-axis at one particular point. Imagine this is the graph. It hits here and it moves. The point of intersection is just 1 point. So in this case, if alpha and beta are the roots, then alpha will be equal to beta and the discriminant will be equal to 0, and the total number of roots will just be 1 in this case because there is only 1 point of intersection. So this is case 2. Now case 3 would be a situation where the graph does not even touch the x-axis. This is the x-axis. The graph doesn't touch the x-axis, so it's above the x-axis. And in this case, the discriminant is going to be less than 0. So there is literally no intersection on the x-axis. So that would mean absence of real roots. So these are the 3 cases that we will have to take into account when we are solving graphical questions involving quadratic equations. Now the same criteria can be applied for a being less than 0. So in this case, clearly a is greater than 0. So if a is less than 0, the cases would almost replicate themselves. Only thing is that the graph would be a little bit different. So instead of being U-shaped, it will be inverted U-shaped. So this would be the graph, and it will cut the axis, the x-axis at 2 points, alpha and beta. So in this case, alpha is not equal to beta, and we call them, the roots are real and distinct. So when we use the word distinct, it means they are unique. So that is the understanding you will have to gather here. So whenever we call the roots are real and distinct, we are talking about alpha and a beta such that alpha is not equal to beta. They are unique, they are not the same. So in this case it is inverted, and here also the criteria is a is less than 0 and the discriminant would be greater than 0 here. So this is the first case. The second case is when the discriminant is equal to 0. In that case, the graph would hit the x-axis at one particular point. Say this is alpha, and alpha will be equal to beta, and the discriminant would be equal to 0. So in this case, we are not talking about distinct roots. We are talking about a root which is basically occurring twice. So alpha is equal to beta. So there is only 1 point of intersection, and that would mean the roots aren't distinct. So that is the understanding that we gather here. So the case number 3 is a situation where there isn't any intersection with the x-axis. So the graph would be something of this fashion, and the discriminant would be less than 0. So this is for all cases when a is less than 0. So we're going to be graphing this quadratic equation. We've been given y is equal to x squared negative 7x positive 12. Now this is of the form, the general quadratic equation ax squared positive bx positive c, where the value of a, if you were to see, it is 1, which is greater than 0. So this would mean we are looking into a graph which is U-shaped because of the very fact it is greater than 0. So that is the first point that we will have to obtain. Now after we have got the first point, we will have to now look into the roots. Right, that is very much the need, because we want to know how many roots the particular equation has got. So for that, you can adopt formula method or you can adopt factorization. So I'm going to adopt factorization. So it's going to be 12 there and negative 7. I need to find two numbers which when added gives me negative 7 and which when multiplied would give me 12. So clearly you can place the negative sign. When you add, you get negative 7. When you multiply, you get 12. So the factorization part is, if I were to take x squared negative 7x positive 12 is equal to 0, This is going to be x negative 4 times x negative 3 is equal to 0. From here you get x is equal to 4 and x is equal to 3. So there are 2 points of x. So that means there are 2 intersections. Now this is the second point. Now the third point, there is something called as axis of symmetry, which can also be obtained, and for that y is equal to negative b over 2a. This is the formula. So clearly, if you were to look into the equation given, in place of b you have negative 7, in place of a you got 1. So 7 divided by 2 is the axis of symmetry. So that's nothing but 3.5. So this is a very important concept that you will have to also find when you're drawing the graph. Now next is the point of intersection on the x-axis, not on the x-axis, on the y-axis. Point of intersection with the y-axis. So we are being given y is equal to x squared negative 7x positive 12. So to get the intersection for the y-axis, we take x is equal to 0. So that would mean y is equal to 12 is the point of intersection. So having got all of this, we are now set to graph the given quadratic equation. So let me just draw the x-axis and the y-axis. This is the y-axis, and the 2 points, if this is going to be 1, 2, 3 and 4, the values are, let me show you, 3 and 4. So this point is 3, this point is 4. There are 2 cuts over here. That is imperative. And then if I were to take this as 2, 4, 6, 8, right? The unit divisions as 2, because I need to plot the point 12. So 2, 4, 6, 8, 10, 12. So this would be the point of intersection at the y-axis. So there is a cut there. Now we need to also get the coordinate of the vertex, which we have not obtained. Axis of symmetry we have got the axis of symmetry. Axis of symmetry is going to be 3.5. You see that this is the axis of symmetry. So probably you can draw that line. So this is the axis of symmetry. And what is the equation? Y is equal to 7 over 2. So that is the equation for this particular line. Now we need to get the vertex, right? Of course I know it is a U-shaped. For getting the vertex, we need to have the coordinates. So this is point number 5, coordinate of the vertex. So what is the formula? Negative b divided by 2a, comma, negative d divided by 4a. So this is the value that would give us the coordinates of the vertex. Now d is nothing but b squared negative 4ac. And we could have actually obtained this value d instead of going on to factorize, because this would give us, if the roots are, just with this we can determine the nature of the roots, but it's still okay. Now the value of b from the given question, it's going to be negative 7. So I'm substituting negative 7 squared, negative 4 times a is 1 and c is 12. This is going to be 49 negative 48, which is 1. So it's greater than 0. So the roots are real and distinct, but it doesn't matter. We have already found out the roots. But this has given us the value for d. So the coordinates in this case is negative b over 2a. That has been found to be a 7 over 2. That's fine. And the value of d is negative of 1. So this is going to be 1 divided by 4 times my coefficient of a is 1. So if you were to rewrite this, is going to be 7 over 2 comma negative 1 over 4. So I have 7 over 2 here and negative 1 over 4. If this point, I'm taking it each of these entries as 2, so this is going to be negative 2 here. Negative 1 over 4 would be somewhere over here. So 0.25, right? So if this entire segment is 2, approximately you can have this as negative 1/4. It's not to scale, just to show you. So that is going to be my coordinates for the vertex. So if I were to put the coordinates, this is going to be 7/2. 7/2 is the x coordinate, and coming to the y coordinate, it's going to be negative 1/4. So this is the point. So the graph will actually touch this and move up, and it will hit the y-axis at 12, and it's going up. It is going up. It will just go up. Now, after having obtained all of this, there's one particular thing you can also obtain, which is called the range. Now, in range, all you need to do is you need to get the minimum values for this particular graph. That is important. So, the minimum value that y can take in this case is going to be negative 1/4. That is the minimum value, right? This is the point when x is 7/2, the y value is going to be negative 1/4. So that is the minimum value that y is taking. Now next comes, what is the maximum value? See, you can clearly see the graph is moving up. There is no stoppage for this graph. The graph will just continue to go up. And if someone were to ask you what is the maximum value that y can take, naturally it's going to be infinity. So this is the range for what? For the function f of x is equal to x squared negative 7x positive 12. So we have obtained all of the informations that are required to graph this particular quadratic equation. Now before we wrap up, if someone were to ask you what is the domain for this particular function, clearly you can see that x can take any value in R. So this is the domain. So just to give you a top up. This question, students, we are asked to graph this particular function. Y is equal to negative x squared positive x positive 1. So foremost, if we are to comparing this given quadratic equation, comparing with say ax squared, say y is equal to ax squared positive bx positive c, then this would mean that the value of a is negative 1 less than or equal to 0. This means the graph is inverted shaped parabola, right? So probably you can use an indefinite article. A graph is an inverted U-shaped parabola. Okay, that's the first inference. You don't have to keep comparing all the time with the general quadratic equation, but just to be consistent with the logic, I've just done that. Clearly you can see that the coefficient of x squared is negative 1, so it's less than 0, so it's going to be inverted U. Now next, this is point number 1. Point number 2 is we will obtain the discriminant to find the number of distinct roots possible. So d is equal to b squared negative 4ac. So that's going to be 1 raised to the power of 2 negative 4 times. My a is negative 1, my c is 1, so it's going to be 1. So this is equal to 1 followed by negative, and I did not place the negative sign for, well, that looks fine. So this is going to be 1 negative negative positive, so 4 times 1, that's going to give me 5. So this is greater than 0, so this means we have got 2 real roots. 2 real roots. 5 greater than 0, so therefore we got 2 real roots. Now the most important point is to obtain that 2 real roots. So how are we going to do that? We've been given y is equal to negative x squared positive x positive 1. So I will be using the quadratic formula, negative of 1 plus or minus root of, the value of d is 5, just place that value 5, divided by 2 times a is negative 1. So it's going to be negative 1 plus root 5 divided by negative 2, that is 1 root. Probably we can write it as x1. And the next root is negative 1 negative root 5 divided by negative 2. Now we need to calculate these values. So let's do that. Now the value of root 5, I'm going to take it as 2.23 divided by negative 2. So this is equal to 1.23. Of course the numerator has got a positive sign, but it has to be divided by negative 2. So we place a negative sign there. And this is going to give me negative 0.61 and then a 5. So I will just take it as negative 0.61. So this is one root. The next root is going to be negative 1 added with 2.23 divided by negative 2. You got negative everywhere. So it's going to be negative 3.23 divided by negative 2, which is going to be positive. So 1.6 and then 1. So this is going to be the next root, right? So we need to now obtain the axis of symmetry. So let me do that. Axis of symmetry, and that is given by the formula negative b over 2a. Now in this case my value of b is 1, my value of a is negative 1, so that's going to give me 1 over 2, which is 0.5. That is going to be the axis of symmetry. So let's see how it works out. Now after the axis of symmetry, we need to obtain the coordinates of the vertex, right? And that is given by negative b over 2a comma negative d over 4 times of a. Now b over a with a negative sign is 0.5, that is already got, and my d value is found to be as 5. So place the negative 5 divided by my a value is negative 1. So this is going to be 0.5 comma 4 divided 5 divided by 4, 5 over 4, which is going to be 0.5 comma 1, and it will be approximately 2.5, right? So this is going to be the coordinate of the vertex. So we've got all of this. So let's just plot the graph. This is the x-axis, this is the y-axis. The roots are, you can clearly see, negative 0.61. So if I were to take this as 1 and negative 1, negative 0.61 would approximately be somewhere over here. This is 0.5, 0.61 is going to be over here. This is one root, and the graph is opening up downwards, so it's an inverted U. So let me write that down, negative 0.61, and then the other root is going to be 1.61. This is the next root we have got, 1.61. If this point is going to be 2, 1.61 would be approximately over here. So that's positive 1.61. So that is one root. And next, the axis of symmetry is 0.5. Clearly see that? We got that. 0.5 is going to be over here. And I can draw that axis of symmetry. Right? And the vertex is 1.25. So if this point is 1, 1.25 is, if this point is 2, 1.25 would be approximately somewhere over here. So this is going to be the point. And the function is y is equal to negative x squared positive x positive 1. So when x, if you want to find the y-intercept, right? So to get the y-intercept, we put x is equal to 0, which means 0 comma 1 is the y-intercept. So there is a cut here. So if I were to join these points, it's going to be something like this, right? And the vertex, let me write the vertex 0 comma it's going to be 0.5 comma 1.25. That's going to be the coordinates of this vertex. So if someone were to ask you the range, what would your answer be? The range. So in this case, the maximum point that this particular graph can take with regard to y is going to be 1.25. So 1.25 is nothing but 5 over 4. So I can clearly write that as 5 divided by 4, comma, it goes down, all the way down it goes, comma, negative infinity. So that is the range. And the domain is what? Domain is nothing but all x such that x is element of real number. So that is going to be the domain. So what are the things we have got? We have got the roots, we have got the axis of symmetry, this is the line of symmetry or axis of symmetry. We got the coordinates of the vertex, and we've got the range, and we got the domain, and we have plotted the graph with neatness. So that is the end of this particular question, students. Now just a quick word, if you're not happy with this representation, you can always have the representation like this, negative infinity all the way up unto 5 over 4. So you can also use this interval representation if you're not happy with this. Welcome students. In this class we will start off by learning about the sign of quadratic expression. So imagine you are given a quadratic expression ax squared positive bx positive c. Now they are asking you, is it positive or negative? Now that would largely depend on two important components. One is a and the other is discriminant. If a is greater than 0 and the discriminant is less than 0, this quadratic expression, if you were to take it as a function and draw the graph, then it will not have any intersection on the x-axis, no intersection with the x-axis. So that would mean the graph would always be on the positive side without having anything to do with the x-axis. So this is how the graph will look. And for this to happen, this is the case. A greater than 0 and the discriminant be less than 0. Now there is the next case that would also come in handy. So this is case 2. In this case, A is less than 0 and the discriminant is also less than 0. So if you were to look into the graph would not have anything to do with the x-axis because of the fact that d is less than 0. And since a is less than 0, the graph will be opening downwards. So this is how the graph will look. Now since we have the topic as sign of the quadratic expression, in the first case, ax squared positive bx positive c will always be positive. In the second case, ax squared positive bx positive c will always be negative. So have that in mind. Let us do this question, students. We've been given this quadratic equation. If ax squared positive bx positive c is equal to 0 as imaginary roots and a comma b comma c is greater than 0, then find the possible graph of y is equal to ax squared positive bx positive c. And we have been given 4 choices. Choice A, the graph looks like this. Choice B, the graph looks like this. Choice C, the graph looks like this. And choice D, the graph looks like this. Okay, now since we have already learned about the concepts, it isn't much difficult to find out the right solution. Now clearly it says that A, B, C are greater than 0. So that means A is greater than 0, right? A is greater than 0. That means a U-shaped graph. Imaginary roots. It has imaginary roots. That means there is not going to be any intersection with the x-axis. There's not going to be having any intersection with regard to the x-axis. So this is not the graph because it is not U-shaped. This is U-shaped, this is U-shaped, this is U-shaped. But apparently in this case there is an intersection with the x-axis. So this is not going to be the graph. And in this case, between B and C is going to be the choice. Now, clearly in both the cases there aren't any intersection with the x-axis. Okay, but the another important quality of the graph is that one is on the right side, the other is actually to the left side. So in this case, if you were to look into the coordinate of the vertex which we have studied, it's given as negative b divided by 2a comma negative d divided by 4a. So we don't need this, but we need only this. It's negative b divided by 2a. So that would mean it is actually on this end, on the negative end, and that is only possible if b is positive and a is positive, correct? But in this case, if you were to see, negative b divided by 2a is actually giving us a positive value. So that would mean this is only possible if b is negative, right? If b is negative, then the graph would be facing this side with the coordinate being present on this positive side of the x-axis. But that contradicts the statement of the problem. Clearly it says b is greater than 0. So that would mean this is not the right choice. And the only right choice is this. So option B is our solution to this question. Students, let's do this question. The question is as follows: if b is greater than a, then the equation x negative a times x negative b negative 1 is equal to 0, as the choices are given. So we are expected to pick one of these choices, maybe one or maybe more than that. We are not sure of it, but I can give you the choices. So it is stated that this equation as both its roots in a comma b, choice B as both its roots in negative infinity comma a, choice C as both its roots in b comma infinity, or as one root in negative infinity comma a and the other b comma infinity. So we are expected to find where the roots for this equation lie, and the intervals are given here. Now let me consider this. Consider x negative a times x negative b negative 1 is equal to 0. If you were to look into the coefficient of, find the coefficient of x squared, what is it we get? It is actually 1, which is greater than 0. So this would mean it's a U-shaped graph. U-shaped graph. So that is the first point you will have to pay attention to. Point number 2, b is greater than a. So if I were to draw the x-axis and the y-axis, b is greater than a, it means that you have a point a and b would be on the right side, right? So this is going to be the point. Now find out what is f of a. if I were to substitute x is equal to a, I would get negative 1, and find out what is f of b. F of b, if you were to substitute x is equal to b, you would get negative 1. So if our point negative 1 is over here, then this is going to be my f of a and f of b. Now, a very important observation, which is a is greater, in fact the coefficient of x squared is greater than 0, which means the U-shaped graph, and the only possibility for the graph to be is this. This is how the graph would look like. Of course, this would be the intersection of the point. So this would be the shape of the graph given the parameters that we have looked into. Now, having got that, clearly we can see there is a root here. There's a presence of a root here and a presence of a root here. So this would mean there is a root. There is a root. Where does it start? It starts from, on this end, it's negative infinity to a. There is a root present in negative infinity comma a to a, and there is also another root present from b to positive infinity, and there is a root present in where? From b to positive infinity. So which of these choices suits us? One root is in negative infinity comma a, and the other root is in b comma infinity. So this is our right choice. So that's a lovely question, students. Let's do this question, students. The question is as follows. Consider the graph of a quadratic trinomial. That means it has got three terms. That's the simplest way to refer to. Given that y is equal to ax squared positive bx positive c, and that x1 comma x2 are the roots of ax squared positive bx positive c is equal to 0, and we are asked to find the correct choices. So we have been given this particular graph, y and x, and the graph flows in this following fashion, and there is one intersection on the y-axis, and there are 2 points, x1 and x2. So the choices that we have are as follows. A negative b negative c is less than 0. Choice B. B times c, is it less than 0? Choice C. B greater than 0. Choice D. B and C have the same signs. Okay. Now it's a MCQ question, multiple choice type. So that means more than one choices can also be fitting into the requirement. So from this graph, what can we see? Now it is inverted U shape, so that means A should be less than 0. So that is the first observation we have. And the next observation is that you can clearly see that the coordinates are on the positive side of the axis. When I talk about coordinate, I am talking about negative b divided by 2a. Of course, this is the axis of symmetry also. And clearly you can see that this is on the positive side. That means negative b over 2a is positive. And given that a is negative, we have a situation like this. Negative b divided by 2 times of negative a. And this is producing positive. So that would only infer that the value of b cannot be less than 0, right? If it is less than 0, it would be negative. So negative of negative would make this numerator to be a positive quantity, and that would give us a negative value, which would contradict the value of negative b over 2a being present on the positive side of the x-axis. So clearly this means that b is greater than 0. So two inferences we have got. We have got A value, we have got B value. Next, you can clearly see this is the intersection, right? And it is on the positive side. So that would mean C is also greater than 0. So from here, B times C is greater than 0 because B is positive, C is positive, and B times C is greater than 0. So that would mean this choice is not going to be the right one. And coming to A, B is positive, C is positive, but A is negative, right? So that would mean if you add all of these things, definitely you're going to get a lesser value than 0, right? Because the sign of B is not going to have any impact here. So that would make B to be negative. C sign will also have no impact because C is positive. That would make C negative. Already we know A is negative. So sum of all these negative quantities will result in a quantity which is less than 0. So clearly this is one of the choices. Now as I mentioned to you, clearly from the inferences we know B is greater than 0. So thereby this is also a choice, because it's all that it states is B is greater than 0. So that's exactly what we have found out here. And finally, B and C have the same signs. It doesn't talk about what sign, but we know that B is greater than 0, C is greater than 0. That would make them to have the same sign. So definitely D is also the right choice. So our choices are A, C and D. So that is the end of this particular question. Students, will move on to the next one. Welcome students. In this class we will learn about symmetric expressions. Now what is a symmetric expression, or what are symmetric expressions? So I would like to state the understanding of symmetric expressions over here. So these are expressions which do not get altered or changed by interchanging of alpha and beta. So that is the understanding. Now in layman's term, suppose if you were to replace alpha with beta in an expression, the expression remains unaltered. So that is the layman's definition of a symmetric expression. Now I would like to give you all a few examples of symmetric expression. The first and the most popular one is alpha squared positive beta squared. Now if you were to replace alpha with beta and vice versa, beta with alpha, this expression will remain the same. Now let me move on. Example number 2, alpha squared positive alpha beta positive beta squared. The same happens here. If you were to replace all alphas with betas and all betas with alphas, this expression will also remain unchanged. Next one, 1 over alpha positive 1 over beta. These are some of the examples. The next one, alpha over beta positive beta over alpha. Now the good thing is that after having alpha over beta, immediately it is being followed up with beta over alpha, so that the expression gets balanced and there wouldn't be any change when you replace alpha with beta and beta with alpha. And 5 alpha squared beta positive beta squared alpha, the same happens over here. And 6 alpha beta raised to the power of 2 positive beta alpha raised to the power of 2. 7 alpha raised to the power of 4 positive beta raised to the power of 4. And 8 alpha cubed positive beta cubed. It doesn't matter, the expression will still remain the same. Let us do a question, students. We've been given that x squared positive 2x positive 3 is equal to 0 as alpha and beta to be its roots. And the question wants us to form a quadratic equation whose roots are 1 over alpha and 1 over beta. Okay, I'm going to show you two different ways to solve this question. Now, the first method is the common method. You don't need any extra skills for this. So, consider x squared positive 2x positive 3 is equal to 0. And it states that alpha and beta are the roots of this particular quadratic equation. So therefore I'm taking the sum of roots, and that is going to be alpha positive beta, which is negative b over a, which is negative 2 over 1, which is negative 2, and the product of the roots alpha times beta, which is c over a, which is 3 over 1, which is equal to 3. And why did we get this? Because of the fact that the question wants us to form the quadratic equation whose roots are 1 over alpha and 1 over beta. Now, for the quadratic equation whose roots are 1 over alpha and 1 over beta, this is what we are going to do. So, sum of roots alpha positive beta. So in this case, it's the roots are 1 over alpha and 1 over beta. So that's going to be alpha beta. This is going to be beta positive alpha. Now alpha beta is negative 2. I should say alpha added with beta, or beta added with alpha is negative 2. And the product of the roots alpha beta is 3. So this is negative 2 over 3. Now product of the roots. Product, that's going to be 1 over alpha multiplied with 1 over beta, which is equal to 1 over alpha into beta, which is equal to 1 over alpha beta is 3. So this is the product of the roots. Now therefore, the quadratic equation with 1 over alpha and 1 over beta as its roots is of the form x squared negative sum of roots, and sum of the roots is negative 2 over 3 times x plus product of the roots 1 over 3 is equal to 0. So if we were to multiply by 3, this is going to be 3 times x squared positive 2x positive 1 is equal to 0. So this is the quadratic equation that is required. Now, as I mentioned to you, this is the normal method, but we are going to use method 2. Now what is method 2? Method 2 is using the concept of symmetric expression. If the given roots are symmetric, this is the important condition. If the given roots are symmetric, then we can actually follow this method. So in this method, what I wish to do is, since given 1 over alpha and 1 over beta are roots of the new quadratic equation, and clearly they are symmetric, right? 1 over, if you replace alpha with beta and beta with alpha, the roots will still remain symmetric, and clearly the given roots are symmetric. The roots are symmetric. Because they are symmetric, I would like to take, hence let us take 1 over alpha is equal to x. So this means write this equation for alpha. So this would mean alpha is equal to 1 over x. Now, given quadratic equation. So what is the given quadratic equation? Given quadratic equation is x squared positive 2x positive 3 is equal to 0. This is the given. Now this original quadratic equation has alpha and beta as its roots. Now let us consider alpha to be the root of this. It's already given, right? Now since alpha is a root, this would mean you now have alpha squared positive 2 times alpha positive 3 is equal to 0. But what have we taken alpha to be as? Alpha is equal to 1 over x. So substitute that. So this would mean if I were to substitute alpha is 1 over x, I get 1 over x squared positive 2 over x positive 3 is equal to 0. Now all we need to do is multiply by x squared. So if you were to multiply by x squared, you get 1 positive 2 times x positive 3 times x squared is equal to 0, which can be rewritten as 3 times x squared positive 2 times x positive 1 is equal to 0. And this is the required quadratic equation. And this quadratic equation will have roots as 1 over alpha and 1 over beta. So if you were to compare this with this, you can clearly see that both the equations are one and the same. But the only thing is that for achieving this, I need to start off with all these steps and then come to the conclusion. But in this case, you can achieve this within 3 steps. First thing is that you need to take this equation equal to 0, and prior to that just assign 1 over alpha, because we are expecting to find the quadratic equation whose roots are 1 over alpha and 1 over beta. So just take 1 over alpha to be x and write this expression for alpha. And since we know that alpha is one of its roots, this system can be rewritten like this. But apparently alpha has got a value as 1 over x, substitute it, multiplied by x squared, and then you get the new quadratic equation. So this is a method which is applying symmetric expression concept. And to apply this concept, the roots given should be symmetric. The roots which we have 1 over alpha and 1 over beta should be symmetric in nature. In this case it is symmetric, right? So whichever type they are giving, you need to first check if it is symmetric, and then directly you can apply this and then get the result. Let's do another question, students. We are given that (4x squared negative 5x positive 7 equal to 0) as alpha and beta as its roots. You are expected to form a quadratic equation whose roots are alpha positive 2 and beta positive 2. Now clearly alpha positive 2 and beta positive 2 are symmetric in nature. Now the solution, let me show you the solution. Since alpha is a root of say 1, this would mean I can rewrite it as 4 times alpha squared negative 5 times alpha positive 7 is equal to 0. I can write it like this. Now let alpha positive 2 be equal to x. So this would mean alpha is equal to x minus 2. So this is what you need to do. Now after you have taken the expansion, or I should say the representation for alpha, if I were to take this as 2, therefore you can now rewrite 2 as, in place of alpha, substitute x minus 2. So this is going to be 4 times of x minus 2 whole squared negative 5 times of x minus 2 positive 7, which is equal to 0. This can be further rewritten as 4 times of, expand this, x squared negative 4x positive 4 negative 5x positive 10 positive 7 is equal to 0, which can be further rewritten as 4x squared negative 16x positive 16 negative 5x positive 17 is equal to 0, which can be further rewritten as 4x squared. Negative 16x added with negative 5x, that's going to be negative 21x, and 16 with 17, that's 3, and 3 with a positive sign is equal to 0. So this is the new quadratic equation. This is the new quadratic equation with roots being alpha positive 2 and beta positive 2. So this is the end of the solution. Now you can observe one important point, that we did not make use of the sum of the roots formula and product of the roots formula. Nowhere in this particular illustration I have introduced that concept of finding the sum of the roots and product of the roots, because of the fact that clearly we can see that alpha positive 2 and beta positive 2 are symmetric in nature, and owing to that we can directly extract the original quadratic equation. Let's do this question, students. If alpha and beta are the roots of 2x squared negative 7x positive 6 is equal to 0, we are expected to form the quadratic equation. Then the quadratic equation whose roots are negative 2 over alpha comma negative 2 over beta is, so we've been given 4 choices: 3x squared positive 7x positive 4 is equal to 0, 3x squared negative 7x positive 4 is equal to 0, 6x squared positive 7x positive 2 is equal to 0, and D is 6x squared negative 7x positive 2 is equal to 0. So foremost, what I would like to do is I will start off by considering the given quadratic equation. Consider 2x squared negative 7x positive 6 is equal to 0, and it says that alpha and beta are the roots. So I will start off like that. Since alpha is a root, this would mean if I were to take this as 1, therefore I can rewrite 1 as 2 times alpha squared negative 7 times alpha positive 6 is equal to 0. Okay, now we are expected to form a quadratic equation with the roots negative 2 over alpha and negative 2 over beta. Clearly they are symmetric. Okay, so since they are symmetric, now let us take negative 2 over alpha to be equal to x, and from here you extract the value for alpha. So this would mean I now have, if I were to push alpha to this right hand side and bring x down, you get alpha to be equal to negative 2 over x. Now take this value and substitute it here, because already we know that alpha is a root, and because of that we got this. So now you substitute alpha with negative 2 over x. So therefore 2 can be rewritten as 2 times of negative 2 over x raised to the power of 2 followed by negative 7 negative 2 over x positive 6 is equal to 0. This can be further rewritten as 2 times, you square it, you get 4 over x squared negative negative positive 14 over x positive 6 is equal to 0. This can be further rewritten as, with the multiplication of this entire quantity with x squared, this is going to be 8 positive 14 times x positive 6 times x squared is equal to 0, which can be rewritten with 6x squared 14x and positive 8 is equal to 0. So this is what we have got, but this can be further reduced, right? If you are going to be reducing this, we would have the following. So I'm going to divide this by 2. So if I were to divide this by 2, I would get 3x squared 7x positive 4 is equal to 0. This is the required quadratic equation whose roots are negative 2 over alpha and negative 2 over beta. Now we need to look for this choice among the listed choices that we have been given for this question. Now clearly, the moment we see that the choice A is blinking before our eyes. So that is the right solution for this question. Students, we will now do questions connected with what is called as common roots. So they will give us one common root and they will subsequently ask us to extract the other roots. Now let us learn this concept by performing this example. So the question here is, let lambda not equal to 0 be element in real numbers, and we're given that if alpha and beta are the roots of x squared negative x positive 2 times lambda is equal to 0, and alpha and gamma are the roots of 3 times x squared negative 10x positive 27 lambda is equal to 0, we are expected to find the value of beta times gamma divided by lambda. And we have the following choices. A, is it 27, B, is it 18, C, is it 9, and D, is it 36. So these are the choices that have been given to us. This is a lovely question, students. So foremost, what we will do is we will start off by considering the given quadratic equation. Consider x squared negative x positive 2 times lambda. Now it says that alpha is a root and beta is a root. And also let us consider the next quadratic equation, which is 3x squared negative 10x positive 27 lambda is equal to 0, and this has alpha to be a root and gamma is a root. Now the element of focus should be here. Alpha is the only root that is occurring as a common root for both the quadratic equation. So what we will do is, since alpha is a root, this, if I were to take this as 1 and this as 2, I can rewrite 1 to be as alpha squared negative alpha positive 2 times lambda is equal to 0. And since alpha is also a root here, I can rewrite 2 to be as 3 times alpha squared negative 10 times alpha positive 27 lambda is equal to 0. Now I need to get rid of alpha squared. So let me take this now as 3 and let me take this as 4. Now since 3 is here and 3 isn't here, what I will do is I will multiply equation 3 with 3. So that would give me 3 times alpha squared negative 3 alpha positive 6 alpha is equal to 0. This is 3 alpha squared negative 10 alpha positive 27. This is lambda. Okay, this is lambda. 27 lambda is equal to 0. Now change the sign. Negative, negative becomes positive, positive becomes negative. So this gets eliminated. So you got negative 3 alpha, positive 10 alpha. That's going to give me 7 alpha. And over here it is 6 lambda, negative 27 lambda. So that's going to be negative 21 lambda, right, is equal to 0. So from here I can rewrite this to be as 7 alpha is equal to 21 lambda, and alpha is equal to 21 divided by 7. Of course there's a lambda there, and this would mean I get a new value for alpha, which is 7 divides 21 3 times. So this is going to be 3 times lambda. So this is what I have got. Okay. Now having got this value for alpha, now we would have to extract the value. This is the next step, that we would have to get the value for beta. That's the next step we need to focus on. Okay, so this is the first quadratic equation, and we are given that alpha and beta are the roots. Now I'm going to take product of the roots here, which is alpha times beta is c divided by a. My c is 2 times lambda divided by a, which is nothing but 2 times lambda. So you have got alpha beta is equal to 2 times lambda. That's fine. But we just found alpha to be equal to 3 times lambda. So take this and substitute it here. So this is going to be 3 times lambda times beta is equal to 2 times lambda. So beta is equal to 2 times lambda divided by 3 times lambda. Lambda gets cancelled, therefore beta is equal to 2 over 3. So clearly you have found the value of beta. Now you can also subsequently get the value for alpha. So if you were to take sum of the roots, right, or in fact if you were to take the value of beta and substitute it here, still you will be able to extract the value for alpha. Now to extract the value for alpha, clearly we need to find the sum of the roots. Of course, this is not the only way you need to apply. There are several other ways, but I'm just finding the sum of the roots. So if you were to find the sum of the roots, you get alpha positive beta is, this is the equation, x squared negative x positive 2 times lambda. So the sum of the roots is going to be minus b over a, which is nothing but negative of negative x divided by 1, right? But in this case, the coefficient of x is going to be used, so that is going to be just negative 1 there. So this is equal to positive 1. So this would mean you have alpha positive beta is equal to 1, but beta is 2 over 3. So substitute 2 over 3 is equal to 1. So this would mean alpha is equal to 1 negative 2 over 3, which means alpha is equal to 1 over 3. Now this is the value for alpha, but we need to extract the value for lambda. Okay, since alpha is equal to 3 times lambda and alpha is equal to 1 over 3, we can rewrite this as 1 over 3 is equal to 3 over lambda. Therefore lambda value is 1 over 9. Now why is this important for us to extract the value of lambda? Because they are asking us to find what is beta times gamma over lambda. This is required, right? So that is the reason I have extracted the value of alpha, then used the value of alpha to obtain the value for lambda. Okay, so having got that value for lambda, having obtained the value for beta, it's time for us to get the value for gamma. Now for that, let us consider the second quadratic equation. So what is that? That's nothing but 3 times x squared negative 10 times x positive 27 lambda is equal to 0, and this as roots. For example, it states that alpha is a root for this, and then you got gamma also to be a root for this. So alpha and gamma are the roots of this. Now what I would like to do is I would like to extract the product of roots. So the product of roots is going to be alpha times beta. So in this case it's going to be alpha times gamma, which is equal to c over a. In this case it's going to be 27, and you got that constant as lambda there, divided by a is 3, and this is going to be 9 times lambda. So what have you got here? So you got alpha times gamma is equal to 9 times lambda, and we have extracted the value of lambda, right? The value of lambda is 1 over 9, so that means 1 over 9 has to be substituted, giving us a value of 1. So therefore alpha times gamma is equal to 1, but I have extracted the value of alpha, which is 1 over 3. So 1 over 3 times gamma is equal to 1, therefore gamma value is equal to 3. So now you can understand how handy the value of alpha comes in. All that we need to do is just to simply substitute. So therefore beta times gamma over lambda is equal to, beta is equal to 2 over 3, which we have already got, over here, and gamma value is 3, and lambda we have extracted it to be as 1 over 9. So 3 and 3 gets cancelled, you get 2 divided by 1 over 9, you flip this, you get 18. So this is the solution, students, and that choice is going to be B. And that completes the end of this particular question, and it's a lovely question. It involves meticulous handling of these expressions. Students, we've been given a very interesting question. Let's do this question. Let A comma B be element of R and that A is not equal to 0. This is a very important point in this particular problem, and be such that the equation A times x squared negative 2 times B times x positive 5 is equal to 0 has repeated roots. And that repeated root is given to be as alpha. Right? So also alpha is a root of x squared negative 2 times bx negative 10 is equal to 0. Now if beta is the other root of the equation, and when we're talking about the equation, we're talking about this one, because for this alpha is the repeated root, but for in this case alpha is one of those root and beta is the other root. So now if beta is the other root of this equation, then we are expected to find the value of alpha squared positive beta squared. So that is the question. So foremost, what I will do is I will start off by consider A times x squared negative 2 times bx positive 5 is equal to 0. This has got alpha to be a root and the other root is also alpha. So two repeated roots. Now if I were to take the sum of roots, which is going to be alpha positive alpha is equal to negative b over a, which is nothing but negative of negative 2 times b divided by coefficient of x squared is a. So I now have 2b divided by a. So this is what I've got. On the left hand side, alpha added with alpha, you get 2 alpha is equal to 2b over a. Therefore alpha is, you can cancel the 2's, giving us alpha is equal to b over a. So this is what we have got for alpha. Now product of the roots, this is step 1. Let me go to step 2. Product of the roots, alpha is repeated, so alpha times alpha is equal to c over a. In this case is going to be 5 over a. Therefore alpha squared is 5 over a, but my alpha is equal to b over a. Take that value and substitute it here. So if I were to take this as say 2 and take this as 3, using 2 in 3 we get in place, so it's going to be in place of alpha I'm going to substitute b over a raised to the power of 2 is equal to 5 over a. Therefore you get b squared over a squared is equal to 5 over a gets cancelled, therefore b squared is 5a. This is a very important relationship that we would have to utilize. So this is all taking place for this first quadratic equation, ax squared negative 2 times bx positive 5 is equal to 0. Now it's time for us to consider the second given quadratic equation. So that's going to be my step number 3. So consider x squared negative 2 times bx negative 10 is equal to 0. Now clearly alpha is one of the roots over here and the other root is going to be beta. So if I were to take the sum of the roots, alpha positive beta, that's going to be negative b over a, which is nothing but negative of negative 2b. Coefficient of x squared is 1, so that's going to be 2 times b. So this is my alpha plus beta 2b. So this is a very important relationship that we will be using. And next comes the product of the roots. What is that? Alpha beta is c over a, and in this case is going to be negative 10. So you can simply state that alpha beta is equal to negative 10. Now we are expected to find the value of alpha squared positive beta squared. So therefore alpha squared positive beta squared can be rewritten as alpha positive beta raised to the power of 2 negative, I need to get rid of that alpha beta, so it's going to be 2 times alpha beta. Now what is alpha plus beta? It's 2b negative 2 times alpha beta is negative 10, so this is going to be 4 times b squared positive 20. So this is what I've got. Now I've got the value for b squared as 5a, but that is not going to be of any use to me because we need to extract the value and then substitute it here. Now for that, what I wish to do is I would like to utilize this concept that alpha is a root. Now let me use the space here. Since alpha is a root of, say, let me just take it as a, because I've used a lot of numbers here. So this would mean alpha squared negative 2 times b alpha negative 10 is equal to 0. But alpha is equal to b over a. So substitute that. So this is going to be b squared over a squared negative 2 times b over a. So it's going to be b squared over a negative 10 is equal to 0. Right? Now what I wish to do is I would like to extract the value for b squared. And that would mean I need to get rid of this a squared here. So for that I'm going to be multiplying the entire component by a squared. So that would mean this is going to be b squared negative 2 times b squared a negative 10 times a squared is equal to 0. So this is what we've got. But it's time for us to utilize this concept, or I should say this relationship. B squared is equal to 5a. So substitute that. So if we were to substitute b squared is equal to 5a, this is going to be 5a negative b squared is 5a, so that's going to be 10a squared negative 10a squared is equal to 0. This can be added, giving me 20a squared, negative 20a squared. So I need to have some space here, so let me make use of the space. So I got now 5a negative 20a squared is equal to 0. If I were to take, say, 5 out, right, if I were to take 5a out, this would give me 1 negative 4, 5 4s are 20 times a is equal to 0. Now clearly from here 5a is equal to 0, right, or I have got 1 negative 4a is equal to 0, therefore 4a is equal to 1, therefore a is equal to 1 over 4. Now from here 5a is equal to 0, this would mean a is equal to 0. But this is a contradiction. Why this is a contradiction? Because you can clearly see a is not equal to 0. So we have to drop this and then take the value of a as 1 over 4. So I've got the value of a as 1 over 4. Now what we need to do is we need to utilize the value of a as 1 over 4 over here. So this would mean b squared is equal to 5 times a is 1 over 4. So I know our b squared is equal to 5 over 4. So take the value of b squared is 5 over 4, substitute it here. So this is equal to 4 times of 5 over 4 positive 20, the 4 and the 4 gets cancelled. 5 added with 20 would give me 25. So what is that value, 25? That 25 is my alpha squared positive beta squared. I know this problem has been done in very restricted space, but the steps are all clearly visible. I hope that would help. So this is the solution for this question. Welcome students, we've been given this question. If a comma b comma c element of R and the equations ax squared positive bx positive c is equal to 0 and x squared positive 2x positive 9 is equal to 0 have a common root, right? So probably let us have it as a common root. Then find the ratio of a is to b is to c. So let me just write down the given quadratic equation. Consider ax squared positive bx positive c is equal to 0 and their roots, say alpha beta, and x squared positive 2x positive 9 is equal to 0 and they have roots alpha and say some gamma. I do not know how many roots are going to be in common. The question says they have a common root. That's what they can. That's what is given in the question. Now, what we have in the question is this quadratic equation: x squared positive 2x positive 9 is equal to 0. So, before we could make any conclusion with regard to the ratios a is to b is to c, find out the discriminant. Now, what is the formula for discriminant? It's b squared negative 4ac. So, from here, the value of b is 2 raised to the power of 2, negative 4 times a times c. This is 4 negative 36, which is going to be less than 0. So this would mean, if I were to take this as 2 and this as 1, 2 as complex roots. So when you can either say it as complex roots or you can say imaginary roots. So what it really means, say for example, you have a root alpha positive I some p. This is a complex roots. Now we know that complex roots occurs in pair. Since we know that complex roots occur in conjugate pairs, right? So that would mean if alpha positive IP is a root, then alpha negative IP will also be a root for this system. Okay, that is to talk about this, right? Now let us move up to the given equation ax squared positive bx positive c is equal to 0. Now it already has been mentioned in the question that one of the roots is common between them. Now if I were to take that common root as alpha positive IP, right, definitely the root has to be complex because both the roots are complex in this second system. So this system, the first one, should have a complex root. Now as we know, complex roots occurs in conjugate pairs. So this would mean my beta should be of the form alpha negative IP. So that is the important conclusion that we need to draw from the result. So having got that, the ratio, how would the ratio be? The ratio would be of the form A1 over A2 is equal to B1 over B2 is equal to C1 over C2. So this would be the ratio. And clearly the coefficient, you can get the values of, if these values of A1, B1 and C1, and these values are taken as A2, B2 and C2. So clearly the ratios for this particular question, A is to B is to C, which is given here, should be of the form 1 is to 2 is to 9. So that is the solution for this particular question. I hope you all got the gist of it, and we will move on to the next question. Let's do this question, students. Question number 2. If the equation x squared negative 4x positive 5 is equal to 0 and x squared positive ax positive b is equal to 0 have a common root. And if this is the scenario, we expected to find a and b, where a comma b are element of real numbers. So foremost, what we will do is we will have to consider the given system. We got x squared negative 4x positive 5 is equal to 0, and in this case it's x squared positive ax positive b is equal to 0. It says that we have a common root. So if this happens to be alpha, this would also be alpha, but we are not sure of the root's nature for the second root in case of x squared negative 4x positive 5. So what we have to do is to have a picture of that. We need to first obtain our d. So d in this case is b squared negative 4ac, and the value of b is negative 4 raised to the power of 2. So 4 times a times c, this is 16 negative 20, which is clearly less than 0. So this would mean the roots are complex. And what is the exact meaning of this when the roots are complex? This would mean complex roots, they occur in conjugate pairs, right? So that would mean if alpha positive I beta happens to be the root, one root of this particular equation, then alpha negative I beta will also be a root of the same equation. And concurrently, since x squared negative 4x positive 5 and x squared positive x positive b, they share a root common. If alpha positive I beta is that common root, then naturally the other root is going to be alpha negative I beta. So that is the important inference that we need to draw here from. Now once we have got that, and then subsequently we are having the fact that d is less than 0. So this would mean the ratio of the roots would be of the form will be of the form a1 over a2 is equal to b1 over b2 is equal to c1 over c2. So this in turn would mean what is a1 1 and what is a2 1, what is b1 negative 4, what is b1. When we talk about b1, we are talking about the coordinates of the x-axis. So it's going to be 4 divided by a is equal to c1 is 5 divided by b. We are expected to find the value of a and b. So equate these two together. So 1 over 1 is equal to negative 4 over a. Therefore, you cross multiply, a is negative 4, and then you equate this with this, right? Also 1 over 1 is equal to 5 over b. Therefore, b is equal to 5. So this is exactly what the question wants. So we have got that. So that is the end of the solution for this question, students. We'll move on to the next one. Students, we will go up to study the next concept, which is nothing but location of roots. Now what exactly does this mean, location of roots? Say for example, we are given this particular statement. Statement 1, given that both the roots of the quadratic equation are greater than, say, some point x0. So what is the meaning of this? The meaning is the two roots that this quadratic equation has are greater than x0. Now let me draw the representation for this. Now before you could draw the representation for this, it is imperative that you understand that you need to exhaust all possibilities or probabilities for which the two roots of the quadratic equation are greater than x naught. So have that in mind. Now, so if I were to take this point as x naught, the roots have to be greater than x naught. So one of the probability would be this, where alpha and beta, say this is alpha, this is beta, are the roots of this quadratic equation, and clearly they are greater than x naught. Now there is also another probability, and that would be this. Say x naught be the point here, and the graph in this case would be of this fashion, where this would be the root, and in this case alpha is equal to beta, and still this is a valid representation for this statement. On the contrary, if someone were to ask you, is it okay if I were to draw a representation like this, when two roots of this quadratic equation are greater than x naught, is this a valid representation? What's your answer is going to be? The answer is no. It is not. Why? Because there is no contact with the x-axis. The graph does not make any contact with the x-axis. And for the roots to be present, the graph has to make contact with the x-axis. So as far as the right answer is concerned, the first one is accepted, the second one is accepted. So this is the representation for this statement. So let's move on, students. Now in the first two scenarios, we saw a graph which is being U-shaped in nature. But that does not mean that the scenarios cannot be applied for inverted U-shaped. So in other words, if there is a statement which says that the two roots are greater than x naught, then we can also have a situation like this, right? So in this case, clearly alpha and beta are indeed greater than x naught. And this is one scenario. The next scenario can also be like this, right? So in this case, you have alpha is equal to beta. So this situation happens for inverted U-shaped graphs. Okay, so having mentioned this, you might be asking, what is the real need for us to draw these graphs? Okay, that is a valid question. So for example, let me just take this illustration that I have just shown you. Say for example, you have a U-shaped graph with the roots being greater than x naught, and you got two roots, say alpha and beta. Now what are the observations that you can see here? The first and the foremost thing is, for this situation to take place, the discriminant d should be greater than 0, strictly greater than 0. Now if in case the graph happens to be like this, where alpha is equal to beta, in that case d is equal to 0. So just to couple up these two things, the situation that has been mentioned here is possible only when d is greater than or equal to 0. Now what does it mean? I'm actually clubbing the first graph with the second graph. So that is the condition I have listed here. Now condition number 2, we need to look into the value of negative b over 2a. This is the axis of symmetry, right? Now what can you see about the axis? The axis has to fall right through this point, right? So if it were to fall right through this point, clearly the axis negative b over 2a is greater than x naught. That's the next observation. Now the third observation is that you need to look into the functional value. So what exactly does that mean, the functional value? Let me just take the functional value that is corresponding to x naught. Where is it lying? If this point is 0 and this is the y-axis, positive side, this is negative side, clearly you can see that the functional value f of x naught is positive, right? And that same positive value will also occur for the next graph. Even if I were to take x naught for this graph, f of x naught will still be positive because it is lying above the x-axis on the positive side. Now what we can do is we can also include one more observation along with f of x naught, and that observation is a. Now clearly you can see that a should be greater than equal strictly greater than 0 because it's a u-shaped graph, and since it is u-shaped graph, a is positive, and that would mean a multiplied by f of x naught will give us a positive value. So these are the three observations. Now you might be asking me, why are we stating these observations? Now when I say observation, these are the conditions. Now the reason we are stating this condition is to allow us to solve and obtain the solution for the given scenario. So you can consider them as boundary conditions, right? And solving boundary condition is a very important skill in the field of engineering. So that is exactly what we are going to be learning in this particular section. Now we got the next case when both the roots are less than x naught. So suppose if we were to draw the diagram and we have x naught over here, we have to draw the graph such a way that the roots are less than x naught. So one possibility would be like this, where the values are alpha and beta over here, and the next possibility is going to be like this. The point of contact is just going to be at one particular point, and alpha is equal to beta. So this is x-axis and this is y-axis. So from here clearly we can see that d should be greater than or equal to 0. And number 2 is, if you were to draw the axis of symmetry, definitely negative b over 2a is going to be less than x naught. And the third point, suppose if you were to extract the value of f of x naught, then clearly f of x naught is going to be greater than 0, right? Because it's going to be on the positive side of the axis. And since it is a u-shaped graph, since a is also positive, a times f of x naught is also going to be greater than 0. So in fact, instead of saying greater than 0, you can say also say a times f of x naught is positive. So what you have to do is you have to solve all of these conditions and get the solution for the given question. Let's do this question, students. We've been given if both the roots of a quadratic equation x squared negative 2k times x positive k squared positive k negative 5 is equal to 0 are less than 5, then we are expected to find the interval where k lies, right? So this is the question and we are expected to obtain the interval, and we have got the following choices. Is it between 5 and 6? Is it between 6 and infinity? Is it between negative infinity and 4? Is it between 4 and 5? Okay, so foremost, let us draw the graph, right? So the graph will give us an idea, greater an idea, and it will also help us to list out those conditions, and from the conditions, upon solving, we'll be able to extract the solution required. Now it says less than 5, so let me just take this point as 5. So the graph can either be like this or it can be like this. So this can be alpha beta, and in this case alpha will be equal to beta. So the first condition is clearly the discriminant is greater than or equal to 0. Condition number 2, if you were to draw the axis of symmetry, it's negative b over 2a, and that's going to be less than 5, right? Strictly less than 5. And condition number 3, if you were to stretch this graph and extract the point f of 5, clearly f of 5 will be above the x-axis on the positive side. So that's going to be greater than 0. So these are the three conditions which we have got, and we will solve these conditions, and upon solving we'll be able to extract the solution. So foremost, d is greater than or equal to 0. So first let me find out what is d. D is nothing but b squared negative 4ac. So from the question, my b is negative 2 times k raised to the power of 2 negative. My a is 1. My c is this entire quantity. So that's going to be k squared positive k negative 5. So let me expand this. This is going to be 4k squared. This is negative 4k squared. This is negative 4k. This is positive 4. And this is greater than or equal to 0. Positive 4k squared, negative 4k squared gets cancelled. Now there is a small thing. This is negative 4 times negative 5. So it's going to be 4 and 5. So it's going to be positive sign. So this is 4k, negative 4k, positive 20 greater than or equal to 0. System by 4. Positive 5 is greater than or equal to 0. Now moving k with a negative sign to the other side, this would give me 5 is greater than or equal to k, which can also be rewritten as k is less than or equal to 5. So this is the direction that we have obtained. So let's move on. Now let's focus on condition number 2. Now condition number 2 is negative b over 2a is less than 5. And clearly we know that the value of b is negative 2 times k and the value of a is 1. So if I were to substitute that, it's going to be negative of negative 2k divided by 2 times of 1, which is less than 5. So clearly 2 gets cancelled. So we got k is less than 5. So this is the second direction we have obtained. Now the third condition is f of 5 is greater than 0. Right? So that would mean we will have to substitute x is equal to 5 in the function. This is the function. So let's do that. So f of 5 is equal to 5 squared negative 2 times k times 5 positive k squared positive k negative 5. This is 25 negative 10k positive k squared positive k negative 5. And I can take the value of k squared here, and negative 10k added with k would give me negative 9k. 25 added with negative 5 would give me positive 20. Now I need to solve this. So I'm taking let k squared negative 9k positive 20 is equal to 0. If you were to factorize this, this is going to be k negative 4 times k negative 5 is greater than 0 because f of k is greater than 0. So this is going to be greater than 0. Now if you were to draw the number line, say this is 4 and 5, from this graph this is going to be the picturization of this interval, right? K negative 4 times k negative 5. Now we also have the value of k to be less than 5, and there is also another value of k which is less than or equal to 5. So let me draw k less than or equal to 5. So that would going to be all the way starting from 5, it's going to move up, and k less than 5. So k less than 5, that's going to start from here and it is going to be moving up all the way down. Now we are expected to find the intersection of all these values. So if you were to find the intersection, then clearly this is the intersection, right? So if you were to look into the value is going to be from negative infinity all the way to 4. So this would be the solution for this question, and probably we can write k lies in this interval. So if you were to see the choices, the choice would be C, which is negative infinity to 4. So that is the conclusion for this question, students. There is a third case that we will have to look into it, and that case is 1 root is less than x naught and the other root is greater than x naught. Now suppose if you were to represent this, say x naught is the point here. Now there are several possibilities that can arise in this case. The roots can be positioned like this, alpha and beta, with x naught closely inclined towards alpha, and there can also arise another possibility where the graph is actually inverted U-shaped. So this is x naught and the graph is of this fashion. The roots are alpha and beta, right? And clearly in this case, if you were to observe this, there is no need for us to consider the value of d, because definitely the roots are going to be distinct because of the fact that one root is less than x naught and the other root is greater than x naught. So definitely the roots are going to be distinct and we don't need this condition d. Now condition number 2, we were dealing with the axis of symmetry, negative b over 2a. Now you can clearly see that there is no way that we would be able to predict the axis of symmetry, because in the previous cases we had a condition, or we had a situation where negative b over 2a was either greater than x naught or it was less than x naught. So this was the condition that we faced, negative b over 2a being greater than x naught or less than x naught. But in this case, just from the graph, it is totally impossible to make a decision whether negative b over 2a is either greater or lesser than x naught. Okay, it's not possible for us to simply draw the line and say that this is greater than negative b over 2a is greater than x naught, or conversely, or I should say I draw the line on this side and then make a judgment that negative b over 2a is less than x naught. So that is the same scenario for either cases. Okay, when the graph is U-shaped or the graph is inverted U-shaped. Now on the other end, we can also find out the value of, so this condition is not needed, this condition is not needed. So there is only one condition we have to focus on, and that is to locate the point f of x naught. Now clearly the graph is U-shaped here, so A is positive, that is one observation. And if you were to look into the point of f of x naught, clearly f of x naught is going to be lying on the negative side. So if I were to take a times f of x naught, then a times f of x naught is going to be less than 0. And for this, as I mentioned to you, we don't need condition 1, condition 2. There is only the third condition that is available for us, which is nothing but f of x naught. So if you were to draw the line and take the point f of x naught, clearly f of x naught is actually lying above the x-axis, right? So it's on the positive side, but apparently my a is negative here, right? A is negative, a is less than 0 because of the fact that it is inverted u. So in this case, a times f of x naught is going to be less than 0. So this condition is applicable for both the shapes of the graph. So now all that remains is problem solving. So let's see an example and better understand this situation. Let's do this question, students. Find the value of k for which one of the roots of the equation x squared negative of k positive 1 times x positive k squared positive k negative 8 equal to 0 exceeds 2 and the other is smaller than 2. right? That's a question. Now clearly upon observation we see that A is positive, so the graph is going to be U-shaped, and if I were to take this as 2, clearly f of 2, right, this is below the x-axis on the negative frame of y-axis, so that's going to be negative, and you can state that. So this is the only condition we need to use. So f of 2 is less than 0, and if I were to take f of x, so given, what is given, f of x is equal to x squared negative of k positive 1 times x positive k squared positive k negative 8. So f of 2, substitute x is equal to 2, so this is going to be 4 negative of k positive 1 times, this is actually x, right, times 2 positive k squared positive k negative 8. So this is going to give me 4 negative 2k negative 2 positive k squared positive k negative 8. I can rewrite this as k squared positive k negative 2k would give me negative k, and 4 with negative 2 would give me 2, added with negative 8 would give me negative 6, and this is less than 0, so state that. Now if you were to factorize this, this is going to give me k negative 3 times k positive 2 is less than 0. So if I were to draw the graph indicating negative 2 and 3, the points that we are looking in is actually less than 0. So this is going to be the interval. So what is the requirement? The requirement wants us to find the value of k. So this would mean the value of k is present in the interval negative 2 comma 3, right? So this is the interval, and that is the end of this particular question. Now students, there is the next case number 4, where the roots lie between x1 and x2, and we are talking about the function being of the form ax squared positive bx positive c. So this is the condition where the roots lie between x1 and x2 with the function being f of x equal to ax squared positive bx positive c. So if you were to draw the graph, if x1 and x2 are the values, then the graph will either look like this or it can also look like this. So this is for U-shaped graph, and if you were to look for the inverted U-shaped graph, if this point is x1 and this point is x2, then the graph will either look like this or look like this. This is x-axis, y-axis, x-axis, y-axis, right? So in this case, clearly D is greater than or equal to 0. Only then you will be able to have these two intersections. Strictly greater than 0, you get these two intersections. Greater than or equal to 0. In fact, equal to 0. I have placed that equal to 0. And then in that case, there will be one root. And that root will be alpha is equal to beta. Right? Equal roots. So I have just coupled greater than and equal to together. So that is for D. The next two is negative b over 2a, the axis of symmetry, that will be falling in between x1 and x2. So it will be greater than and lesser than. So it's lesser than x2 and greater than x1. So that will be the condition for the axis of symmetry. Now the third point is, if you were to take, say, the intersection of f of x1, or I should say the value for f of x1 and the value for f of x2, then clearly it is going to be greater than 0, because a is positive here and f of x1 is positive along with f of x2, which is also positive, right? Both the values are positive. So a times f of x1 is greater than 0 and a times f of x2 is greater than 0. This condition will also be applicable to the inverted U-shaped. There wouldn't be any change at all, because in this case a is negative, right? And f of x1, if you were to take f of x1, say some point which is touching the parabola, that's going to be negative, right? So a times f of x1 will be greater than 0. Composition of two negative operators, or I should say two negative values, product of those two things are being found here, right? So definitely that's going to be greater than 0. So these two conditions which I've just mentioned will also be applicable to the graph of inverted U-shaped, and also this graph, or I should say this condition will also be applicable along with the first condition. So all these conditions will be common to both the graphs. Let's do this question, students. If both the roots of the quadratic equation x squared negative mx positive 4 is equal to 0 are real and distinct, and they lie between in the interval 1, 5, then we are expected to find the interval in which m lies. Then m lies in the interval, that is what is expected. So we have a few choices. A is -5, -4, B is 4, 5, C is 5, 6, and D is 3, 4. Okay, so this is given. F of x is given to be as x squared negative mx positive 4, and when you are taking it as a quadratic equation, the roots are real and distinct. So if you were to take the points as 1 and 5, since the roots are real and distinct, they would be lying in between, right? And you will have a distinct alpha and a distinct beta. So that is the important observation you will have to take into account. So let me write that down. D is strictly greater than 0 because of the fact that the roots are real and distinct. So number 2 is negative b over 2a is actually, it is, if you were to draw it, it will be falling between 1 and 5. So lesser than 5 and greater than 1. And condition 3, if you were to take f of 1, clearly f of 1 is greater than 0, and condition 4, f of 5 is greater than 0. So let me just calculate D. Now D is nothing but b squared negative 4ac, and from here my b is negative m raised to the power of 2, 4, a is 1, and c is 4. This is going to be m squared negative 4 into 4 is 16, and this is strictly greater, right? That value is going to be strictly greater than 0. And if you were to simplify and write this, this is going to be m negative 4 times m positive 4 is strictly greater than 4. So if you were to draw the graph negative 4 and positive 4, and we are looking at this region, right? And this region, it's open, right? It's not greater than or equal to, it's strictly greater than. So this is the region we are looking at. Okay, so having got this, let us focus on condition 2. Condition 2 is negative b over 2a. It's lying between 1 and 5. So what is that? If you were to look into the value of b, b is negative of negative m, that's going to be positive. So 1 is less than the value of negative b is, that's going to be positive m, right? Divided by 2 times a is 1, and this is going to be m over 2 between 1 and 5. So if you were to multiply throughout by 2, this is going to be 2 less than m less than 10. So that is a nice interval. I'm going to plot the interval after I've extracted these values. So now it's f of 1 is greater than 0. Now, as I mentioned to you, this is my f of x, right? So this would mean my f of 1 is 1 negative m positive 4. So 1 negative m positive 4 is strictly greater than 0. You add these two together, 5 negative m is greater than 0. And then you move negative m to the other side, you get 5 is greater than m, or you can rewrite it like this: m is less than 5. This is one interval. So 4, f of 5 is greater than 0. So that would mean it's going to be, we need to use this function, right? Let me show that to you. We need to use this. F of x is equal to x squared negative mx positive 4. So that is going to give us 5 squared negative 5 times m positive 4 is strictly greater than 0. So it's going to be 25 negative 5m positive 4 is greater than 0. This is 29 negative 5m is greater than 0. And if we were to push this to the other side, it's going to be 29 greater than 5m. Therefore 29 over 5 is greater than m. So this is what we've got. So now the question comes, how are we going to plot it? We need to plot it. So we have got only one interval plotted. So let me plot that first. So this is negative 4 and positive 4. Starts open, right? It goes up like that. That's one. And then let me go to the second case. Between two, m is lying between 2 and 10. So this is 4, 5. It goes like this. And 10. Let me have this 10 to be somewhere over here. And 2. This is 3. This is 2. Right? This is between 2 and 10. So if you were to plot that, it's going to start here. It's strictly right. So 2 and 10, that's going to be over here, right? Probably you can have it like that. Now the next thing is m is less than 5. So if I were to take this as 5, and this is what it goes, m is less than 5, right? And then 29 over 5, m is less than 29 over 5. So all values 29, what is 29 divided by 5? 5 5s are 25, 4.08, 5.8, 5.8, if this point is 6 or so, 5.8 is somewhere over here, right? This point is, let me write that down as 29 over 5. So m is actually less than. So if I were to get that value of m, it will start from here and move on. So now we need to plot the intersection of all these points. So let's do that. So the intersection will actually, I should have started like this. Okay, that's fine. So this is the intersection, and this is open, right? So this would be the region, right, between 4 and 5. Between 4 and 5. So this is the intersecting point, right, between 4 and 5. So from here clearly you can see m is lying between 4, 5. So that is the right answer for this question. So if you were to go and check it out with the choices, then clearly this is the correct choice between 4 and 5. So that is the end of class today. Students, we will see you all again in the next class. Students, this is case 5, location of the roots. Now exactly one root lies between x1 and x2. So if we were to be having x1 and say x2, the roots can be of this form. This is one possibility, and the other possibility can be something like this, right? Or you could have drawn a little bit broader. So these are all unique possibilities. So this is, if this occurs, this would not occur, right? So have that in mind. And if this occurs, this will not occur. And concurrently, if in this case it is a greater than 0, suppose a is less than 0, and you've been given x1 and x2, then this can be one possibility, and also this can be the other possibility. So if this occurs, this will not occur, and if this would have occurred, this will not occur. So if you were to state the conditions, the first condition, we always start with the discriminant, right? But since there is just one root, we don't have to look into this condition. So that would mean this condition is absent. Number 2, we are going to be looking into the axis of symmetry, negative b over 2a. Now usually the axis of symmetry is the line which would be passing through the center of x1 and x2. But in this case, the line can either pass like this, it can pass like this, right? There are these probabilities being present. So since we are not in a position to outrightly determine the presence of negative b over 2a, this condition is also dropped. Now condition number 3. Now let me extend this curve like this, and if I were to find the value of f of x1, now clearly you can see f of x1 is present on the negative side. So if I were to list f of x1, this is on the negative end, and if I were to find f of x2, f of x2 is on the positive side, right? So therefore f of x1 times f of x2, what is it? It is going to be less than 0. Now having mentioned this, there is also a likelihood of the root being present exactly on x2, right? So in that case, f of x2 would be equal to 0. So that would mean there is also a presence of less than equal to condition. So you need to have that into the picture. Now case number 6 is both the roots are outside x1 and x2. So that is the condition. So that would mean if this is x1 and this is x2, the roots would be present like this. So this would be the alpha, this would be the beta, and or the other, this is for a greater than 0, right? For the other end, if this is x1 and this is x2, the roots would be like this, and this would be my alpha, this would be my beta, right? And now we need to write down the conditions, and the only condition that would be valid for this case is f of x1 times f of x2 is strictly greater than 0. There wouldn't be a situation where you have this lesser than equal to or greater than equal to, for the very fact the roots are strictly outside x1 and x2. So this will be the only condition that we would be utilizing. So let's do a question. So the question is, find the set of all real values of lambda for which the quadratic equation lambda squared positive 1 times x squared negative 4 times lambda x positive 2 is equal to 0 always have exactly one root in the interval 0, 1. So if I were to draw the interval 0 and 1, then there should be one root lying between 0 and 1. It doesn't matter where the other root lies. The other root can also be on 0 or it can also be on 1. So if I were to find f of the first point, f of 0, and if I were to stretch this line and find f of 1, clearly f of 0 and f of 1 is going to be less than equal to 0. As I mentioned to you, it is important only one root lies between 0 and 1. The other one can either be on 0 or it can be on 1, and that is the reason we have this line lesser than equal to. So what we will do is we are expected to find the value of f of 0. Now let me just take f of x. This is the system given, lambda squared positive 1 times x squared negative 4 times lambda x positive 2. You find f of 0, this would give us 2, and then you find f of 1, this would give us lambda squared positive 1 negative 4 times lambda positive 2. So f of 0 times f of 1, that's going to be 2 times of lambda squared negative 4 lambda. 1 added with 2 would give me 3, and this is less than equal to 0, right? So if I were to simplify this, this is going to be lambda squared minus 4 lambda positive 3 less than equal to 0. You factorize it, so it's going to be lambda negative 1 times lambda negative 3 is less than equal to 0. So if I were to represent this, you get lambda being an element of, let me just write down the values, 1, 3. Now the point is lambda can take either 1 or 3, right? So this is how I have written, but the main important concept that we need to understand here is we need to take the value of lambda being equal to 1 and lambda being equal to 3 and then check if the roots obtained from lambda being equal to 1 really satisfies the condition of the problem. The problem says find the values of lambda for which the roots lie between 0 and 1. So this is actually an open interval. So that is exactly what the check we need to do, and I will be showing you that. So let me take lambda to be equal to 1, and this is going to give me, in place of lambda I need to substitute 1, so it's going to be 1 squared positive 1 times x squared negative 4 times x positive 2 is equal to 0. This can be rewritten as 2 times x squared negative 4 times x positive 2 is equal to 0, which can be divided by 2, giving us x squared negative 2x positive 1 is equal to 0. When you factorize this is nothing but x negative 1 raised to the power of 2 is equal to 0, which means x is equal to 1 twice. Okay, so x is equal to 1 and x is equal to 1 is actually the roots which are occurring when lambda is equal to 1. So there are two roots, but apparently the roots are repetitive in nature. Now if you were to plot the root, x is equal to 1 is actually occurring on this particular point. Okay, the problem that we have here is, if this particular system would have had another root such that it lies between 0 and 1, then lambda is equal to 1 is an accepted value. But apparently the two roots which we are getting is actually lying, or they are actually lying on x is equal to 1, and that is a big issue for us because this contradicts the statement in the question. So instead of saying lambda is element of the closed interval 1 comma 3, we will have to rewrite this as lambda being element of open interval 1 comma 3 with this side being closed. But I have not gone for lambda is equal to 3 as yet, but this is the decision that I have got because of the fact that x is equal to 1 is occurring twice, right? Now let me substitute lambda is equal to 3. Suppose I take this as a, okay, put lambda is equal to 3 in a. So this is going to be 3 squared positive 1 times x squared negative 4 times 3 times x positive 2 is equal to 0. This can be rewritten as 3 squared 9 positive 1, 10x squared 4 times 3 12x positive 2 is equal to 0. I divide by 2, I get 5x squared negative 6x positive 1 is equal to 0. Now if you were to use the quadratic formula, this is going to be 6 plus or minus root of 36 minus 4 5s are 20 times 1 divided by 2 times 5. This is going to be 6 plus or minus root of 16 divided by 10, which is equal to 6 plus root of 16 is 4 divided by 10. This is 10 over 10, which is equal to 1. 6 minus 4 divided by 10, this is 2 over 10 is equal to 1 over 5, right? Now 1 over 5, what is 1 over 5? 1 over 5 is 0 point, I add a 0 and I get 2, so 0.2, right? I hope you're able to watch it. And one root is 1, the other root is 0.2. So clearly you can see 0.2 is actually present between 0 and 1. So that means, this would mean lambda is present between open interval 1 and closed interval 3. So this is accepted, right? And the choice, if I were to state the choice, these are the following choices you have for this question. Is it 0 comma 2? Is it 2 comma 4? Choice C is it 1 comma 3? And choice D is it negative 3 comma negative 1? So clearly you can see that this is the accepted choice. So that is the completion of this question. Students, it's a beautiful question. It requires some application. Students, the next important concept we need to look into is called as theory of equation. So what exactly is the meaning of this? The meaning is, we have to understand the theory that governs each equation. That is the exact understanding of this particular topic. Actually, if you were to move up the ladder to pursue university education, say specializing in mathematics, then theory of equation is treated as a subject for a semester. So as I mentioned to you, what is this subject, theory of equation, or concept of theory of equation? It's nothing but understanding the theory that governs the equation. Simple as that. So first and foremost, let us consider a quadratic equation. Ax squared positive bx positive c is equal to 0. Now if I were to take the sum of the roots, alpha positive beta, we have the formula as negative b over a, right? And the product of the roots, alpha beta, is c over a. Now how are we getting this? How are we getting this? It's nothing but, foremost, whenever you have a system like this, ax squared positive bx positive c, you divide this by a, So if I were to take this as 1, therefore I can rewrite 1 as x squared positive b over a times x positive c over a is equal to 0. And if we were to take the sum, we always start with a negative and the product would be followed with the positive sign. And always remember, the sign would be alternating. So suppose in case of a third degree system, the roots would have started with negative followed by positive and then negative. And degree 4, the sign would again start, or I should say end with positive. So in that case it's going to be negative, positive, negative, positive. So the signs would be alternating and the starting sign will always be negative. Now let me take a cubic equation, say ax to the power of 3 positive bx squared positive cx positive d is equal to 0. So as I mentioned to you, we will divide this by a. So this is going to be x cubed positive b over a x squared positive c over a x positive d over a is equal to 0. Therefore the sum of the roots alpha positive beta is going to be negative b over a. The product of the roots is going to be c over a, and this is the case for the quadratic equation, right? We always see this alpha positive beta and alpha beta, but in this case the roots are not just alpha and beta. So in this case the roots is going to be, okay, let me write that, the roots here are alpha comma beta comma gamma. Because why? Because the degree here is 3. Degree here is 3. That's the reason. So if we were to write the sum of the roots is going to be alpha positive beta positive gamma, which is equal to negative b over a. Then the product of the roots is going to be alpha beta positive beta gamma positive gamma delta, right? Gamma delta is equal to c over a. And then 3 roots alpha beta gamma is equal to d over a. But in this case, as I mentioned to you, this is negative, positive, and this is going to be negative. Now this is called a sum of roots, and in this case we call it as sum of roots taken 2 at a time. So this is the important way of addressing the system. So as you all know, in this example we are talking about the degree 3 equations, and this is the theory that governs this cubic equation or degree 3 equation. Now having given you this, let me move on with another illustration, or I should say, a better word to say is, let me give the degree 4. So this is a quartic equation. You can either use the term quartic or biquadratic. So the form is ax to the power of 4 positive bx cubed positive cx squared positive dx positive e is equal to 0. So we divide by a, and this is going to be x to the power of 4 positive b over a x to the power of 3 positive c over a x squared positive d over ax positive e over a is equal to 0. So we have a system of theories for this. So what I will do is I will use this space here. So the first thing is sum of the roots alpha positive beta positive gamma positive delta. This is equal to negative b over a. Now taking roots 2 at a time, that's going to be alpha beta positive beta gamma positive gamma delta, and then you need to come back to alpha, so that's going to be delta alpha, right? So I have alpha beta. So this is the first set, but this is not complete because I have not clubbed alpha with gamma. So I need to write that alpha with gamma, and finally I need to club beta with delta. So beta with delta, and this is going to be positive C over A. So this is sum of roots taken 2 at a time, and next one is going to be sum of roots taken 3 at a time, and that is going to be alpha beta gamma plus beta gamma delta plus gamma delta alpha plus alpha beta delta. Right, so this is going to be sum of roots taken 3 at a time, and this value is going to be, this is minus B over A, this is C over A, and this is going to be negative D over A. Now finally the product of the roots, alpha beta gamma delta, this is minus B over A, this is C over A, this is negative D over A, and this is going to be E over A. So as I mentioned to you, the signs are alternating, negative, positive, negative, positive. So this completes the theory, and we will do some questions. Let's do this question, students. We've been given x cubed negative p times x squared positive q times x negative r is equal to 0. We are expected to find the sum of the squares. This is the first part. Second part, we are expected to find the sum of the cubes of the roots of the cubic equation. Now this is the solution. Let alpha comma beta comma gamma be the roots. So sum of the roots is going to be alpha positive beta positive gamma is equal to negative B over A. So my B is negative P, my A is 1, so the value is P, and taking 2 at a time, alpha beta positive beta gamma plus gamma delta is going to be C over A, so that's going to be Q, and taking 3 at a time, alpha beta gamma, that's going to be negative of negative R, right? This is negative B over A, this is C over A, and this is negative D over A. It's going to be negative R of negative R, which is giving us R. So if you were to rewrite this, this is going to be alpha positive beta positive gamma is equal to P, alpha beta positive beta gamma positive gamma delta is equal to Q, and alpha beta gamma is equal to R. Now it says find the sum of the squares. So it wants us to find alpha squared positive beta squared positive gamma squared. Right? So it says when you say find the sum of the squares, they are asking us to find the sum of the squares of the roots. That's the understanding. But this can be rewritten as alpha positive beta positive gamma raised to the power of 2 negative 2 times of alpha beta positive beta gamma positive gamma alpha. This is a formula, right? The identity formula. Now since we know alpha positive beta positive gamma is equal to P, I substitute it, and alpha beta positive beta gamma positive gamma alpha is equal to Q. So this is going to be P squared negative 2 times Q, and this is the solution for the first part, right? For this part. Now we need to do the second part. This part is already finished. Now we need to do this part, so let's do that. Now for part 2, we are expected to find the sum of the cubes, alpha cubed positive beta cubed positive gamma cubed. This is what is required, right? So for this we will use, we know that the all important identity. What is that? Alpha cubed positive beta cubed positive gamma cubed negative 3 times alpha beta gamma is equal to alpha positive beta positive gamma times alpha squared positive beta squared positive gamma squared negative alpha beta gamma and gamma alpha. So this is the identity which we will be employing. So this is equal to alpha positive beta positive gamma, we already know, right? So that's equal to, it's going to be p times alpha squared positive, beta squared positive, gamma squared. What is that? That's going to be this value. So p squared negative 2 times q negative, if I were to take the negative sign out, alpha beta positive, beta gamma positive, gamma alpha. What is that? That is going to be q, right? So substitute that value there. So it's going to be q, and if I were to rewrite this, this is going to be p of p squared negative 2q negative q, which is p of p squared negative 3q. But this is not the end, because we expected to find alpha cubed positive, beta cubed positive, gamma cubed. So this means alpha cubed positive, beta cubed positive, gamma cubed. You push this guy to the other side, so that's going to be p of p squared negative 3 times q positive 3 times alpha beta gamma. This is equal to p of p squared negative 3 times q positive alpha beta gamma. What is the value alpha beta gamma? We got it to be as r. So place that. So 3 times of r. So if you were to rewrite this, this is going to be p into p squared. That's p cubed 3 p cubed positive 3r. So this is nothing but alpha cubed positive, beta cubed positive, gamma cubed, and that is the solution. Let's do this question, students. We've been given that there is a cubic equation we expected to solve. So solve the cubic equation 4x cubed positive 16x squared negative 9x negative 36 is equal to 0, given that its sum of two roots is equal to 0. Right? Now let me start like this. Let alpha, beta, gamma be the 3 roots. Now it says that sum of the 2 roots is equal to 0. So that would mean, this means if I were to add alpha with beta, I should get 0. And that is only possible if beta is equal to negative alpha, right? Of course, you can club alpha with gamma, and in that case, gamma will be equal to negative alpha, right? Because the sum has to be equal to 0. So hence, the roots are alpha, one is alpha and the other is negative alpha, and the third root is gamma, right? So you add the first and the second, you get 0. Now let me take the sum of the roots. Alpha plus of negative alpha plus gamma is equal to negative b over a, right? We need to get negative b over a. So let me consider the given system. 4x cubed positive 16x squared negative 9x negative 36 is equal to 0. Make the coefficient of x cubed to be as 1. So you divide by 4. And that would mean you get x cubed plus 4x squared negative 9 over 4 times x, negative 9 is equal to 0. And this is going to be negative b over a. So this is going to be negative 4. Right, so negative alpha, positive alpha gets cancelled, giving me gamma is equal to negative 4. That's fine. Now we need to extract the other roots, right? So this is the first step. Now I will move on to the second step. I will take the product of the roots. So I will take alpha with negative alpha and with gamma. So this is actually the total product, right? When I take the sum of the roots 2 at a time, that is going to be c over a. This is going to be negative d over a. And what do we have d in place of d? This is b, c and d. So this is going to be negative 9 over a is 1. So this is equal to 9. So this is what you have here, right? So alpha into alpha, you get alpha squared with a negative sign. Of course, there is a gamma value which is -4. You can place that, which is equal to 9. Negative negative will become positive. So you get alpha squared is equal to 9 over 4. Therefore, alpha is equal to 3 over 2. This is alpha. So if you were to sum it up, let me write this value here. The first root being alpha, which is 3 over 2. The second one would be -3 over 2, and the third one is going to be -4. So this is the solution for this question, students. Let's do this question, students. The values of m for which x squared -2mx positive m squared -1 is equal to 0 as both its roots such that one root is greater than -2 and the other is less than 4, and we've been given the choice for m. The choice for m is the value of m lies between -2 and 0. Our choice 2 is it m greater than 3? Choice 3 is it between -1 and 3? Choice 4 is between 1 and 4. Right? Now let's start this question. We are given, this is what is given, x squared -2mx positive m squared -1 is equal to 0. The value of a is greater than 0. That's important observation. Now we are expected to locate the values of m for which the roots lie between -2 and 4. So one root is greater than -2 and the other root is lesser than +4. So the roots are actually lying over here, right? And the requirement is that we locate the value of m. In fact, we are expected to locate that interval. Now there are a few things we can outrightly confirm. That is, the value of d is greater than 0 because the roots are real and distinct, right? That's an observation. Number 2 is the vertex, or I should say the axis of symmetry. The axis of symmetry will be the line that has to go in between the parabola, right? And that is given as minus b over 2 times a. So minus b in this case is going to be negative of -2 times m. My a is 1. So if my a is 1 and my value of b is present there, this is going to give me the value of m, right? This is going to be the value of m, and clearly this m should lie between -2 and 4, right? Clearly this m should lie between -2 and 4, right? See, that is the understanding. In fact, that is the inferences that we get, right, from the graph, from the very picturization. Now, how are we going to get the value of m? Now, for that, it's very simple. What you need to do is you need to you need to get the value of f of negative 2 and the value of f of 4. So case 1 is when you have a times f of minus 2. A is positive, f of minus 2 is also positive, so this is going to be greater than 0. That is the case that we will get here. And since we know the coefficient of a is 1, it's okay that we find the value of f of minus 2. Substitute the value here. So it's going to be negative 2 squared, negative 2 times negative 2, positive of negative 2 squared, negative 1. This is equal to 4, negative, negative, positive 4m, and positive 4, negative 1. So this is going to give me 3 positive 4. Apparently, so this is going to be giving me f of minus 2 is equal to negative 2 raised to the power of 2, negative 2 times negative 2, positive m squared, negative 1 is going to be 4, negative, negative, positive 4m, positive m squared, negative 1. You add this together, you get m squared positive 4m, positive 3. But a times f of minus 2 is greater than 0. So this would mean 1 multiplied with m squared positive 4m positive 3 is greater than 0. Now if you were to factorize this, this would give us m positive 3 times m positive 1 is greater than 0, right? Now what is the outcome of this inequality? This would mean m is equal to negative 3, m is equal to negative 1, and we are looking into values towards the right and values towards the left, right? Because of the very fact that m positive 3 times m positive 1 is greater than 0. Of course, this side will produce me positive values, this segment would give me negative, this segment would give me positive. So we are looking for all values towards the right of negative 1 and all values towards the left of negative 3. So that is for case 1. Now having got that, let me go on to get case 2. Case 2 is a times f of 4 is greater than 0. So f of x is x squared negative 2 times mx positive m squared negative 1, and f of 4 is going to be 16 negative 2 times m times 4 positive m squared negative 1. This is 16 negative 8m positive m squared negative 1, and you can rewrite this as m squared negative 8m positive 15, right? If you factorize this, this is going to be m minus 3 and m negative 5, and this is greater than 0. So if you were to draw this, this is 3, this is 5, it's greater than 0, all values on to the left and all values to the right. So values to the right of 5, values to the left of 5. So this is what we have got. Now we have to club these two together to get the value for m, interval for m, right? Now according to the question, we are looking for values between negative 2 and the positive 4, and you have negative 3, so this is negative 2, negative 3 is going to be over here, this is negative 1 and 0, and you got a value 3. So if this is 1 and this is 2 and this is 3, let us take this to be as 5. So this is an important line which we need to mark. We will mark that first. So after we have marked it, this is negative 3 to negative 1. So negative 3 all values, so to negative 1, And if I were to draw this like this, say for example, let me stretch from -1 to it goes all the way, right? That's the meaning of this. From here it starts, it moves up to the right side of -1. In this case, it moves up towards the left side of -3. So that's for the first case. In this case 3, so if I were to move up like this goes like this, and 5 move up like this goes like that. Okay, now where is our boundary? So this is our boundary, and this is another boundary, right? So now we are expected to look for the intersection of all the values. Now if you can clearly see, there is a -1 here, right? -1 is present from here and then it moves, and there is a intersection of -1 with +3, right? So this is the intersection that we are looking for, and apparently this intersection is lying between -2 and +4. If you were to, we can't take in these values because there is 5 is out of the bound, right? 4 is over here, 5 is out of the bound, and as far as the 3 is concerned, 3 is inside the bound, and it is basically intersecting with the values from -1. So this is the region that we need to look into, or I should say the values for which m holds good. So that would be -1 less than m less than 3, -1 less than m less than 3. So the m is actually lying between -1 and -3. And if you were to take the values of m between -1 and -3, see, this is the equation given, right? X squared -2 times mx positive m squared -1 is equal to 0, right? Now if I were to take, say, m is equal to 0, if m is equal to 0, then what happens here? This goes off, so I get x squared -1 is equal to 0, which means x squared is equal to 1. Therefore x is equal to -1 or +1, right? That is the understanding that we get, because in fact from here I can rewrite this as x -1 times x +1 is equal to 0, which in turn would lead me to -1 and +1 values. Now the question is or are these roots -1 and +1, do they lie between -2 and 4? Yeah, -1 is over here and +1 is over here. So for this value of m, which I've taken, clearly I can see that the roots are lying between -2, it's greater than -2, but it is less than +4. You can check other values also. If you were to take m is equal to 1, the same will be true. If I were to take the value for m is equal to 1, this is going to give me x squared -x positive m is equal to 1, right? +1 -1 goes away, so you get 0 is equal to 0. This is nothing but x of x minus 1 is equal to 0. So x is equal to 0 is a root, and x is equal to +1 is a root. So 0 is greater than -2, but 1 is less than 4. So this is the answer, students. We'll move on to the next question. Let's do this question, students. If alpha, beta, gamma be the roots of the cubic equation x cubed positive qx positive r is equal to 0, then find the equation whose roots are alpha positive beta, comma beta positive gamma, comma gamma positive alpha, alpha positive beta, beta positive gamma, gamma positive alpha. Now let us start by consider the question, the given equation. Consider x cubed positive qx positive r is equal to 0, which can be written as x cubed positive 0 times x squared positive q times x positive r is equal to 0, right? Since alpha, beta, gamma are the roots, clearly by taking the sum we see that if we were to take the sum of the roots, alpha positive beta plus positive gamma is negative b over a. My b is 0, so this would mean alpha positive beta positive gamma is equal to 0. Now from here we can see that alpha positive beta is equal to negative gamma. Now I can also rewrite this as alpha positive, clubbing with gamma is equal to negative beta. I can also rewrite the same thing as beta positive gamma is equal to negative alpha. Now the question wants us to find, from the question we are expected to form, you can use either the word form or find the cubic equation whose roots are alpha positive beta, comma beta positive gamma, comma gamma positive alpha, right? Now we know that alpha positive beta is equal to negative gamma, so this is equivalent to finding, the cubic equation whose roots are, instead of alpha positive beta I can replace it with minus gamma, minus beta, and minus alpha. So if we were to rewrite this, rewriting, we get, so what do we get when you rewrite? We are actually looking for minus alpha, minus beta, minus gamma to be the roots, right? So actually we are looking for a system, a cubic system which has this to be the roots. Now from here I have moved up to this spot. I have moved here, right? Because of the very fact that I have alpha positive, beta positive, gamma is equal to 0, right? So that should be clear. So now let me move on. Now this is the original system. Given that x cubed positive qx positive r, okay, this is r, is equal to 0, as alpha as its roots, as in fact beta and gamma is also the roots of this system, but we are taking alpha to be the root, as alpha as one of its roots. So this would mean x is equal to alpha, right? So if I were to take this as a, I can rewrite a to be as alpha cubed positive q times alpha positive r is equal to 0. Fair enough, right? So from here we move on. We are looking for, what are we looking for? We are looking for a cubic equation where x is equal to negative alpha, right? This is the point. So from here this would mean alpha is equal to negative x. and if I were to take this as b, therefore I can rewrite b as negative x raised to the power of 3 positive of q times negative x positive r is equal to 0, which can be rewritten as negative x cubed negative q times x positive r is equal to 0, which is nothing but I'm multiplying by negative 1, so multiplying by negative 1, so this is going to give me x cubed positive q times x negative r is equal to 0. What is this? This is the required cubic equation whose roots are negative alpha, negative beta and negative gamma. Alternatively, they are, what are they? They are alpha positive beta, beta positive gamma and gamma positive delta, right? So this is the solution for this beautiful question. Let's do this question, students. If alpha comma beta comma gamma be the roots of x cubed positive q times x positive r is equal to 0, then find the equation, the cubic equation whose roots are alpha beta, beta gamma and gamma alpha, right? So let's move to the next page and work this question out. Now let me just start off by considering the given equation. Consider x cubed positive qx positive r is equal to 0. This is going to be x cubed positive 0 times x squared positive q times x positive r is equal to 0. Now since alpha comma beta comma gamma are the roots, I can take the product of the roots. This means alpha beta gamma is equal to minus d over a. This is b term, c term, a term, d term, and the value of d is r, the value of a is 1. So this means alpha beta times gamma is equal to negative r, right? Negative r. Now from here I can rewrite alpha beta to be equal to negative r over gamma, or I can rewrite beta gamma is equal to negative r over alpha, or I can write alpha gamma is equal to negative r over beta, right? Since we are required to get the equation whose roots are alpha beta, beta gamma, gamma alpha, equivalently the question is solved if we can obtain the equation whose roots are negative r over gamma, negative r over alpha, negative r over beta, right? We can, this is equivalent to starting from negative r over alpha, negative r over beta, negative r over gamma, right? So that is sufficient. So now since coming back, right, since alpha is the root or one of the roots, since alpha is one of the roots of x cubed positive q times x positive r is equal to 0. This means I substitute alpha here. Alpha cubed positive q times alpha positive r is equal to 0. Right. Also, we are looking for an equation which has one of its roots to be x is equal to negative r over alpha, right? So I'm going to be using this and this, right? So this would mean alpha is equal to negative r over x. If I were to call this as say b, using this in b, we get, so what do we get? We get, in place of alpha, I'm going to substitute negative r over x raised to the power of 3 positive q times negative r over x positive r is equal to 0. This is negative r cubed divided by x cubed negative q times r over x positive r. This is what we have got. Is there anything else? Okay. Now you got r, this is equal to 0, and r can be taken out, giving us negative r squared over x cubed negative q over x positive 1 is equal to 0, and multiplying by negative 1, this is going to be r squared over x cubed positive q over x negative 1 is equal to 0, and multiplying throughout by x cubed, this is going to be r squared positive q times x squared negative x cubed is equal to 0. So I think we should not have multiplied by negative 1 because of the turn of events. The equation has become like this, and then we will have to revert back the equation, right? Or what we can do is we can move, instead of again multiplying by negative 1, I'm moving everything to the right. So this is going to be x cubed negative q times x squared negative r squared is equal to 0. This is what we have got. Let's do this question, students. We've been given f of x to be equal to 2 times x squared positive mx negative 13x, this is squared positive n, as 2, 3 its roots, as 2, 3 as its roots. Now find the value of m and n. So you got a m here, you got a n here, and this is a cubic equation. It's 2x cubed, right? It's 2x cubed positive mx squared negative 13x positive n, right? This is the function given, and it is said that if the function has 2, 3 as its roots, we are expected to find the value of m and n. Now 2 and 3 are its roots, but this is a cubic equation, so it will have 3 roots. So solution, I'm going to take, let 2, 3, alpha be the roots of f of x, right? Now taking sum of the roots, so if I were to take sum of the roots, it's going to be 2 positive 3 positive alpha is equal to negative b over a. So that is going to be negative m. The coefficient of x cubed, which would give us the value for a, is equal to 2. So this is equation 1. So taking sum of the roots 2 at a time. 2 times 3 is 6, 3 times alpha, and then 2 times alpha, that is equal to c over a. Now c over a is actually 13 over 2. That's fine. So this can be rewritten as 6 positive 5 alpha is equal to negative 13 over 2, equal to negative n over 2. Now what I wish to do is, I would like to consider the second equation. Okay, from 2 what we got 6 positive 3 alpha positive 2 alpha is equal to negative 13 over 2, and this can be rewritten as 6 positive 5 alpha is negative 13 over 2. I move this negative 13 over 2 to the left, that will be positive, right, 13 over 2, and I move this 5 alpha to the other side, it's going to be negative 5 alpha. This is going to give me 25 over 2 is equal to negative 5 alpha. 5 divides here 5 times, therefore alpha is negative 5 over 2. Fair enough. Now I have got also equation 1, right? So from 1 I have got a relationship like this: 2 positive 3 positive alpha is equal to negative m over 2. Substitute the value alpha here. This is 5 positive of negative 5 over 2 is negative m over 2. This is 10 negative 5 divided by 2 is negative m over 2. 2 can be cancelled. This is going to be 5 is equal to negative m, therefore m is equal to negative 5. So I've got the value for m, and I can substitute it here. If I were to take this as 3, so what does 3 give us? It gives us 6 alpha is negative n over 2, and I got the value for alpha substituted here. So this means 6 times negative 5 over 2 is negative n over 2. 2 gets cancelled, negative will become positive, therefore n is equal to 30. I got n value, got m value, therefore m comma n is negative 5 comma 30. So this is the solution, and if they give this question as an MCQ, then the probable choices can be A, negative 5 comma 30, B, negative 5 comma, this is negative 30, and C 5 comma 30, and D none. Right, so obviously D is the right choice, and we have shown that here. Thank you, students. Enjoy your day.